So think about a graph where on the x-axis you have salary for a job, right? So on the left-hand side, like very low paid, right-hand side, very high paid. And then on the y-axis, you have how exposed jobs at that level are, right? So for robots, you have a line that basically starts high on the left and then goes down a lot. So it's very low-skilled jobs, so it's low-paid jobs that are exposed to robots, and high-skilled jobs are not at all exposed. For software, you have a very different pattern, which is that actually the lower skilled jobs are not that exposed and the highest skilled not that exposed. It's the middle skilled jobs that are most exposed. But the really interesting thing is for AI, it's a completely different pattern again. It's actually the sort of upper middle skilled jobs that are most exposed. So the line kind of starts in the bottom left at like a low level and then goes up and up and up and up, and it peaks, I think, at the sort of the 88th percentile of jobs as by salary, right? So like really, really upper income, sort of high paid jobs, and then sort of goes down at the very top. The CEOs paid the most and not exposed so much, but the sort of the lawyers and the accountants, whatever, they actually are exposed.
This episode is just so good. You're in for a treat today. Or at least I loved it. So you're in for a treat if you have tastes like mine. I learned so much listening to this one over the weekend. Luisa interviews economist Michael Webb of DeepMind, the British government, and Stanford University about how AI progress is going to affect people's jobs and the labor market, something which he has been studying for many years now. Will we see mass employment anytime soon? Whose incomes are going to go up and whose are going to go down? How widely shared will all the benefits likely be? Will regulation greatly slow down deployment of all of this technology? How likely is it that AI could lead to explosive economic growth? And of course, what can we learn from history? And what reasons are there to think that perhaps this time it really is different than all of the times that we've seen before? Louisa and Michael are so thorough that it's not until the second hour that they actually get to those arguments for expecting AI to be a really exceptional case. So if you're wondering why they're not more seriously contemplating futures that get strange, just stick around. That said, Michael's expectations for the economic effects of AI in the short to medium term aren't as radical as some previous guests, like Tom Davidson, who spoke about his modeling of a really rapid economic takeoff earlier in the year. So I'm glad we have this interview so that you can hear every different angle on this question. All right, without further ado, I bring you Luisa Rodriguez and Michael Webb.
Today, I'm speaking with Michael Webb. Michael most recently served as a senior aide to Rishi Sunak, where his brief covered everything from UK's economic response to COVID, to artificial intelligence, the UK's science budget, higher education, startups and venture capital, setting up ARIA, the UK's new R&D funding agency, talent visas, and many other policy areas. Before serving in government, Michael was a research scientist at Google DeepMind and received his PhD from Stanford University. He's published articles on a wide range of topics and was co-author of the now famous article, Are Ideas Getting Harder to Find? And he's also done influential work on the topic we'll be focusing on today, the impact of artificial intelligence on the labor market. Before Stanford, Michael studied at Balliol College, Oxford, and MIT. He was also at various points an organ scholar and choral conductor, an epidemiology researcher at Harvard, and a war correspondent for The Economist, where he reported from Afghanistan. Thanks for coming on the podcast, Michael.
Thanks for having me. It's great to be here.
So I hope to talk about the impact AI will have on the labor market over the next few years, and in particular, how it'll affect our jobs. But first, often I know a lot about guest positions on the broader topic of AI before they're coming on, if we're gonna speak about AI. And I actually don't know that much about yours. So I'm curious how excited or worried you are about, the development of AI and possibly AGI.
Awesome. So I have been somewhat engaged in this question for quite a long time. So more than 10 years now. I've sort of, been hanging out with people who think that the end is nigh, or at least, big things are going to happen very, very soon. And actually, the very beginning of my PhD in 2014, I sort of decided that this seemed like kind of the most important question that people could possibly be thinking about and studying. And so, ended up sort of pivoting all of my research to focus on that question. And as part of that, I ended up working with DeepMind for several years as a research scientist, and did a bunch of different things. One of the things I did which again I can't say much about because for obvious reasons it's quite confidential, but it was some kind of exercise that you might call today a sort of timelines or forecasting exercise to think about what was happening with AI sort of in the world and what it would be able to do at different points in the future. So yeah, can't say much about that. However, I think one thing I'm sort of comfortable sharing is one thing that everyone in all of DeepMind pretty much agreed with was the following claim. So we were talking about, different capabilities that might become possible with AI at different points in the future. And one capability we talked about quite a lot was, would an algorithm be able to write an undergraduate level essay on Foucault?
Okay.
Michel Foucault being the famously abstruse French philosopher, and who I had, the reason I sort of used it was because that was my hardest week in all of my undergrad. I was having to write an essay on Foucault, and indeed I ended up spending much more than a week doing it in the end, and had a great time, but it was extremely hard. And so I was like, that's like a nice benchmark of a hard task.
Right.
And so I asked this question to all these people at DeepMind, all these researchers, and everyone universally agreed that an algorithm would not be able to write an undergraduate level essay on Foucault for a very, very long time from now. So, say, sort of the 2040s at the earliest.
And when
right?
was this again?
This was in 2017, I should say.
Okay. So at least a few decades. Yep.
So 6 years ago now, right. And so, as you might guess, when I got access to GPT, I guess GPT-3, sort of the text Da Vinci 003, whatever that was, in 2020 for the first time, 2021, the first thing that I put into it was this essay title that I had to answer myself as an undergraduate a decade ago. And it did a pretty passable job. Like, it clearly passed my sort of internal mental benchmark of like what a decent undergraduate essay on this would look like. And so that for me was this very visceral feeling of, here's this thing that like the smartest people with all the, the knowledge and on the cutting edge and, in the world thought, a small number of years ago was completely decades away. And like these people were themselves sort of on the leading edge of being optimistic about this. And then here we are, something that was going to be, 10, 20, 30 years away. Suddenly we just like rushed past it in, 3, 4, 5 years. So that was a sort of feeling of, okay, whatever I think in terms of how fast things will be or how long they could take, it's possible for me to be very wrong on the side of, things moving much faster than you expect, right?
Right.
And so I guess the question for me is like, do I sort of say, okay, let's take how fast things actually were between 2017 and 2022, say, and just assume that will continue. I was sort of too low before, it's going to be faster. Or do I think, actually, you know what? Sort of what we did was to sort of, we took the kind of the linear forecast from 2017, and it turned out it was sort of the second derivative. It was like the acceleration was what was happening, and so we actually need to continue forecasting the acceleration. And I think we can have a long discussion about this, and I think it's probably the answer is somewhere in the middle, and maybe there's been acceleration, and maybe it's going to sort of, it'll slow a little bit for various reasons. But broadly, I think, we are at already an incredible level of capabilities, which we'll spend a lot of time talking about, I guess, for the rest of this conversation. There's a lot of kind of very obvious low-hanging fruit with what we already have to make it ever more, more effective. And I, strongly suspect that we're going to see at least, what we saw from GPT-3 to GPT-4 is the same again, right, in the next year or two, seems pretty likely. And, that's going to be huge because the first thing was enormous, right?
Right, that's already huge.
So the answer is,
Yep.
But I think that GPT-4 is, I'm curious how whether you think this is a sort of obvious or a controversial statement. And it seems to me that it is better than the average human at pretty much everything where you can make a fair comparison, i.e. it's a text in, text out type thing. That's a massive deal, and I think people haven't sort of got their heads around how big a deal that is.
Totally. I think there's a thing where they're like, well, it can't do this super well. And so like, it's still clearly limited. But like, if you take most of the things it can do well, it is just like, both much better at that thing, and also has like a bunch of things it's like insanely better at, including just like productivity. Like even if like the one essay on Foucault is only like somewhat better than the average student's, it could write thousands of them in a day. And I feel like people miss some of the ways it's not just like roughly parity or somewhat better, but also just like worlds better in a few other important ways. But go on.
So yeah, I guess, these elements we'll discuss in lots more detail over the course of today vis-a-vis economic impacts. I imagine some listeners at least will be very bored by now of hearing people geek out about exactly what it can do and how great it is.
Sure.
So I don't want to sort of spend lots of time sort of sharing my personal experiences of all of that, other than to say I think it's completely amazing, and I spend depending on the day it is, like if I'm in meetings all day, then no, but if I'm all day just on my laptop doing whatever it is, I would easily spend 3, 4, 5, 6 hours a day, interacting with GPT-4 or Claude for the most part. And it's just been transformative for sort of many, many areas. And pretty much anything you can think of, it's like there's a way it can really transform things. So the answer is yes, I'm extremely excited and also, concerned, because this is going to have, huge impacts, and there's, all kinds of, safety issues as well, which, you have covered well on this podcast with other guests that I think are, incredibly, incredibly serious and important.
Cool. Well, let's dive into your area of expertise. So as you've said already, there's been a lot of public discussion about how AI systems like large language models might affect the economy and the labor market since the release of, GPT-3 and 4. You've already hinted at some of the capabilities, but I was particularly blown away by some of the test scores it got. So it scored in the 88th percentile on the LSAT, the 99th percentile for the verbal GRE, the 80th on the math GRE. It got 5s on the AP exams in biology, macroeconomics, and microeconomics. It did much worse on writing-oriented exams, but still, the overall picture seemed to me to be that, these LLMs are just getting really good at some types of things. And as you said, good enough that they might be able to contribute more and more to the economy. And again, you've alluded to this as well. There seem to be loads of anecdotal reports of people using LLMs in their day-to-day lives. And I'm wondering if there have been any particular developments that you found, especially surprising or impressive.
Yeah. So many, but let me just, I guess, mention a couple of them. So the first one is everything that it can do with code. So in particular, the fact that I can just say, make me a, interactive visualization that does this, or create something for me that, has these properties or whatever it is. It can just create that. And so something that would have taken a software engineer, a full day's work or something, I've got lots of sort of engineering experience, but I haven't made front-end apps or whatever. And in this case, recently I was making a front-end app that I wanted to use for something. Just did it in like 20 minutes. They're like done from like end to end.
Wow.
And so that was just like, this is amazing in terms of what it makes possible, the sort of the reduction in cost of highly customized software or widgets or sort of who knows what in sort of so many different areas. And then this also means that you can interact much more easily with existing systems. So often you have this friction of some new technology comes along and there's like tons of work that have to be done to sort of integrate it into your existing system. So it kind of plays nicely with everything else. But because the way that one quote plays nicely with other things generally involves code of some kind. Well, the GPT, it can write its own code. It can do it for you, and so it sort of makes the interaction much more seamless and quick to achieve. So that's kind of one sort of bucket of things. And a second one, very quickly, is the fact that you can sort of hook it up to other things, not just kind of to integrate it or whatever into a wider system, but sort of the point where the thing itself that you care about is what's coming in and going out of the algorithm. So say we're sort of answering physics problems, right?
Uh-huh.
The fact that now, it's been shown that it's super easy to hook up an LLM to, say, a calculator is the obvious, simple example, right? So it turns out that just like humans, LLMs are not that great at mental arithmetic, sort of coming out the block. However, you can give it a sort of a prosthesis of a calculator, and it can learn to query the calculator, and it can know when it's when it needs to do so, and then get much better answers. But you can take this to a much broader sort of area, right? So one paper I saw, I guess last year now, that I thought was amazing and also very scary, I think it was a DeepMind paper where they were training an algorithm on answering physics questions. And they said, here's what it does if you just use the language model, with train of thought prompting and various tricks that people have figured out are important. But then separately, let's take a physics simulator. So, over the last decades, people have made all kinds of, fancy software that is carefully designed to do particular tasks really, really well. And one kind of such software is a sort of physics simulator, and which you just, you sort of encode all the rules of Newtonian mechanics and whatever into the simulator.
Right.
And
it's doing something like, if you do all this stuff to all these particles, where will the particles end up?
Yeah, exactly.
Just
that kind of thing.
Yeah. Okay, cool.
Precisely.
Great.
Yeah. And so what the algorithm learns to do is you give it some hard natural language physics question. It then learns to turn that physics question into code it can use to query the fancy physics engine, right? And then on the other end of that engine, the engine produces some code as output, and then it can then read the output code, turn that back into natural language, and produce the answer to the original natural language physics question, right?
That's a huge deal.
And so that's just massive, right? And you're seeing this all the time today with, in sort of perhaps more prosaic, but, really, really important areas like querying databases, right? Or, all kinds of things. And so the fact that these are kind of, in a similar way to humans, we are, our brains can do certain things, but they're way better when they have, paper to write on and books to look things up in, or the internet, or friends to ask, or whatever it is. And these models, they can do all those same things. And so it means that, it's just incredible, the sort of, that they're unlimited almost in what they can do, but because they can access all these other things. They can be extended so much more easily.
Right. Yeah, I agree. That is huge. Moving on a bit to the thing, we're especially interested to talk about today. There seems to be a huge range of views held by experts in these fields. I guess economic papers, but also corporate research studies and government white papers. About how big of an impact these systems will actually have on the economy. So will all of those uses have real impacts, I guess, not just on the economy, but also, the labor market. So whether it'll cause more unemployment or reduce people's wages or increase or decrease income inequality. And you wrote this great paper on which jobs are kind of most and least exposed to AI substitution. So this thing where, AI automates away certain tasks. And I guess how that might affect people in different industries and income inequality in particular. And I want to find out how your views have changed since you wrote the paper. But before we do that, I want to dive into the paper in some depth first. Let's take things step by step. And actually, for context, the paper you looked at the jobs that were most exposed to AI based on kind of just the AI capabilities that existed and had been written about in 2020, which is when you published the paper. Is that right?
That's right, yeah. And in fact, a tiny bit before 2020 because, these papers take a little while to write.
You wrote the paper beforehand. Yeah.
And it's worth saying a little bit about sort of the methodology sort of very, very quickly. So
great.
There's a whole line of papers that try to think about the impacts of the exposure of particular jobs to particular technologies. And what they generally do is they say there's a bunch of sort of data on what's involved in particular tasks in particular jobs. So in particular, the US Bureau of Labor Statistics has sponsored for a long time this wonderful project that goes down to basically looks at every job in the economy and writes down exactly what's involved in that job.
Oh, cool.
In a sort of standardized way. Yeah, so all these papers all use that in various iterations. And so you hand me a description of what a doctor does, say, interprets tests to diagnose patient's condition, whatever, right? So what I do with that task description is I say, it's very hard for me to sit around and sort of cleverly decide what's going to be automated because of some technology. Let's use sort of the hive mind and much, much smarter people to figure out what's going to be automated. And a really good place for that is the text of patent. So a patent, if you have an invention, you've got a patent saying, this is my invention, I might use it. And patents, what they do is, there's many, many patents for, every application of AI you can possibly think of. And so that means that sort of all these inventors have done the hard job for us of thinking what's actually worth automating with AI. And because patents go back literally hundreds of years, the same thing has been done for everything from steam and electricity to, you know, more modern IT and robots and so on and so forth. And so you can sort of back test the method and see if it works in some sense. And a benefit of this is that patents are kind of forward looking. So at any point in time, you sort of file a patent today, basically before your invention is adopted. So think about the 20-year adoption curve, whatever, for some technology. Generally, the patent is like year 0 of that, or year -3 or 5 or something, right? So it is actually very forward-looking. And so it means you're not sort of engaging in wild speculation, nor are you sort of asking people who don't really know much about automation or anything like that. You're going to the actual experts who have incurred a cost, so it costs like $10,000 or $20,000 to file a patent. So you would only do it if you're like quite confident it's actually going to happen. So it's a way of sort of, you can think of it as like you're sort of aggregating the forecasts of a huge decentralized sort of people in the actual economy who are really incentivized to make the right decision here about their forecasts.
Who are putting money on this bet.
They're putting money, exactly. They're putting money on the bet, right? So that was kind of my idea. And I did this, but to be clear, there's other ways of doing it, right? So I guess the original way of doing it was so when the BLS sponsored government people go and collect this data on tasks, they don't just collect the task word of the sentence describing it in language. They also will have whole kinds of other dimensions of like, does this task involve upper body strength? Does it involve, writing at the level of a college graduate, whatever it is, right? And so there's loads of these things. And so the very first kinds of papers that did this kind of exercise, 20 years ago, they picked some of those dimensions and said, let's take this dimension as capturing what it is that software can do. And then what more recent papers have done, so there's a paper that came out very recently by some folks at OpenAI and some of their co-authors, and they basically wrote down a prompt of like, here is what we think GPT-4 can do. And they got GPT-4 to go and read all the text, descriptions of the tasks and got it to label them as to whether GPT-4 thought itself that GPT-4 could, substitute for these things, right? And they also had some human labelers and they compared the human labelers with the GPT-4 labels. But broadly sort of, asking people you recruit, I don't know whether they use, Mechanical Turk or Upwork or whatever to sort of, to find the human labelers. And you're generally getting kind of people who know they're sort of smart, but they're not generally domain experts in all the different domains of all different automation, right? So kind of the advantage of my thing is that you're actually relying on the sort of skin in the game forecasts of actual experts in these areas, and you can backtest it. But there's also plenty of kind of bad things about patents. We can have a long discussion about like why patents are a bad measure for this kind of thing. So there's no one right or wrong method. And you hope that different methods produce similar results for the things you care about. Or that would be nice converging evidence, on certain kinds of impacts. And indeed we see that in some things, which we'll talk about in a second.
So a thing that had been done before was like looking at, not just jobs, but like the kinds of skills required for those jobs, and then making educated, guesses about whether technology has the skills to automate away those jobs or those tasks. And so you mentioned upper arm strength, and I guess that's like, if some manufacturing jobs require upper arm strength and then you get robots that like, I don't know, that are strong, then maybe it like meets the criteria for automating away that particular job, or at least like part of the job. And then you can make predictions about how many of those tasks are going to be automated away by that technology. And then there's this other version where you're asking GPT-4 to actually make predictions about which tasks it's going to be able to automate away. But your methodology, which I think is really cool, looks at patents which basically require kind of domain experts, at least kind of experts, to make predictions that cost some amount of money to make about what their technology is going to be able to do. And then I guess you do some sort of matching from like the text in the patents to the types of skills reported as being required for these jobs. And then you're like reasonably confident because they're putting money on that technology being able to eventually automate away those tasks. And so we think that those jobs with those kind of tasks are going to be exposed. Where exposed, I guess, just means like, at risk of being either automated away or having their jobs basically impacted by that new technology. Am I basically getting that right?
Exactly right. Yeah.
Okay, great. That makes lots of intuitive sense to me. Okay, so you said that you kind of came up with this idea and then you actually applied it to other technologies besides AI to figure out, like, does it actually capture the thing and then make the predictions that like line up with what actually happened? What technologies did you do that with, and how good did the methodology seem to perform?
Yeah, so I did it with robots and software as well as AI, and that's what's in the paper. Also spent much of time doing it for steam and electricity.
Okay.
It's not on the paper because there's a bunch more work to do on that, and it's really hard because you're dealing with like very ancient archival documents that have to be digitized and stuff. But anyway, it definitely is doable for those as well. And so for robots and software, it was pretty, I'd say, like reasonably compelling in terms of what came out as sort of what is exposed and what is not exposed. So one example for software, who's exposed? Parking lot attendants. So what do? They go around and sort of, record number plates and issue, tickets saying, yes, I've agreed to park here, whatever. That's exactly what software embedded in a, parking machine, whatever, can do. And so, great, of course, software takes over that. You don't really have parking lot attendants anymore. Or many, many fewer. And so something that wasn't exposed was a barber or a podiatrist, which makes complete sense because there's nothing software could do in that. And so in terms of AI, this is where I guess it shows up that I'm looking at patents kind of pre-2020. So
right.
People were sort of thinking very hard about what AI could do based on, the current state of the art and what might be possible. They hadn't seen GPT-4, and so they generally hadn't patented loads of text-based stuff. They'd done a bit that sort of seemed plausible, but they hadn't spent loads of money saying, yes, this is definitely going to be possible because we've seen it. And so what I found was most exposed to AI were clinical lab technicians. So people who sort of, stare at microscopes and sort of do visual interpretation of images. So that's, AI can do that. Chemical engineers. I got friends running startups that are, using AI to automate chemical engineering. Optometrists. So optometry is, one of the areas of AI in medicine which is performing really, really well. Like it can just do stuff with eye scans. Power plant operators was a top one. When I was at DeepMind, one thing we did was use AI to automate the cooling system of a data center. It's a very similar job, I think, to sort of power plant operation in some respects. And so that was just happening. And then the final one was dispatchers, taxi dispatchers. Of course, that's exactly what the Uber algorithm does. Right. So I was most pleased with these exposed occupations because it sort of felt like, yes, these are exactly the ones that sort of add up. And then the least exposed were animal caretakers, food preparation workers, postal service mail carriers, college professors, and arts and entertainment performers. Which again, all seem like pretty like things that AI is not going to do much with because they all very involve human interaction and they involve all kinds of other stuff, physical labor as well, often, right?
Yeah, interesting. Those make lots of sense. But yeah, I guess there's been loads of progress since you wrote that paper. So very curious if you've had any big updates on specific jobs since the paper was written. For example, you might have said fashion modeling isn't very exposed, and then maybe Midjourney makes it incredibly exposed. Maybe musicians soon, for example. What have been your updates?
Yeah. So I guess there's kind of my intuitive updates, and then there's sort of what are people who have done, sort of taken my method or, done similar things to my method, and sort of what have they found with more up-to-date data. And so this OpenAI paper that, did something, very much in the same spirit as what I was doing, which was itself the spirit of what others before had done, but, using these, much more up-to-date sort of exposure descriptions, as it were. They're not using patents, they're doing something else. But they found... for them, the most exposed occupations to GPT-4 were interpreters, translators, journalists, poets, writers, mathematicians, court reporters, right? So very much things that that makes sense. GPT-4 could do that.
Yeah, it's interesting though, because it does make sense now, but it doesn't sound like any of those were in the paper from 2020, which I guess highlights how quickly things changed, how much wider the scope for task automation has gotten since then. And it's been 3 years.
Yes. Yeah. GPT-4 is these sort of large language models that just feel to me like a completely different thing to the AI that was being studied in 2018.
Right. So those are some, I guess, specific types of jobs that might be automated away or that might just be exposed and impacted by GPT-4. Were there broader patterns?
Yeah. So I think, for me, the most interesting thing in kind of my paper and also in the OpenAI paper, which they sort of talked about but sort of haven't commented on that much in the paper itself, is so what I think these measures that we're both using, right, they're very noisy measures. Like, there's all kind of errors that are going to be showing up in terms of particular jobs because of in their case, the way the prompt was written, in my case, because of idiosyncrasies of patents and whatever, right? And so sort of you're on slightly safer ground by taking a step back and doing some averaging. Right, so any particular job, there could be some noise. But on average, you can sort of say things about sort of categories of job or people or whatever it is. So I did a lot of work in my paper looking at, okay, if you sort of aggregate and just think about, how does exposure vary overall on average as a function of, how much education you have, or how much your job is paid currently or whatever it is, right? And so, I found a really interesting pattern of results comparing AI to these previous technologies. So what I found was that, so think about a graph where on the x-axis you have income or salary for a job, right? So on the left-hand side, like very low paid, right-hand side, very high paid. And then on the y-axis, you have how exposed jobs at that level are, right? So for robots, you have a line that basically starts high on the left and then goes down a lot. So it's very low-skilled jobs, so it's low-paid jobs that are exposed to robots, and high-skilled jobs are not at all exposed.
Got it.
The software, you have a very different pattern, which is that actually the lower-skilled jobs are not that exposed and the highest-skilled not that exposed. It's the middle-skilled jobs that are most exposed. And what's cool is that this sort of reflects a pattern that lots of other very careful research in economics has found about the impacts of software in particular, in terms of like it's really impacted middle school jobs.
Empirically, exactly.
Like really careful studies, specifically of software, it's middle school ones that are most exposed. So it's like cool that I kind of replicated that with this very different method.
That is really cool.
And then, but the really interesting thing is for AI, it's a completely different pattern again. So for AI, it's actually the sort of upper middle skill jobs that are most exposed. So the line kind of starts in the bottom left, at like a low level, and then goes up and up and up and up, and it peaks, I think, at the sort of the 88th percentile of jobs by salary, right? So like really, really upper income, upper sort of high paid jobs, and then sort of goes down at the very top.
Okay.
In terms of, so the CEOs pay the most and not exposed so much, but the sort of the upper, the lawyers and the accountants, whatever, they actually are exposed.
Fascinating.
And just quickly before we go to the story, the really interesting thing is that the OpenAI paper, using a different methodology and focusing very much on GPT-4 and these new large language models, as opposed to the sort of a slightly earlier vintage of AI I was focusing on, they like kind of replicate this figure and with their measure, and it's basically exactly the same.
Wow.
So the same
that's
pattern.
Cool. Really validating.
Now, actually, turns out that many of those jobs are the most regulated jobs. So the doctors and the lawyers and the accountants, they're the ones who actually have the most power in the economy and society to put up barriers and stop the exposure that might otherwise cause them to, be paid lower wages or whatever. They can pull up the drawbridge and stay happy as they are. But on the sort of the pure economics of this, sort of before getting to the sort of political economy, this sort of fancy pretend world where there's no actual humans and there's no politics, it's those jobs that are most exposed. Yeah.
Were there any other findings from that paper that are worth pointing out?
So I think actually there's some different papers, some follow-on papers on the sort of differential impacts across different kinds of people. So what my paper and this more recent one we're talking about is sort of there are different jobs and different jobs get paid different amounts on average, and it looks like the sort of the higher paid ones are going to be more exposed. You might also ask though, a given kind of job will have different kinds of people doing it, right? So there are brilliant genius doctors, and there are very novice ones who are just starting and don't know very much yet, right? For example, right? Are these different kinds of people going to be impacted differently by, for example, having access to GPT-4 or something similar? And so there's some really interesting papers that have sort of started to look at this experimentally. So they actually recruit real people and give them access to GPT-4 or whatever it is and see what happens. And so my favorite one of this, I think, is very well done and is like a really sort of cool experiment, is work by Eric Brynjolfsson, Daniel Lee, and Lindsay Raymond, called Generative AI at Work from earlier this year. And they did a really big study in a real company, and they got. It was basically technical support, sort of customer service chat agents. So sort of real humans typing over chat, guessing there's some sort of help button, they pressed it, they get the live chat with the customer support person. And they did an experiment where they were like, okay, sort of the control group doesn't get access to, I think in this case, it wasn't like they were giving them, hey, you've now got an extra window open on your computer, which is GPT-4 or ChatGPT. It's like, no, we've actually embedded it. We've built it into the software that's sort of helping you inside the chat system. So it's going to suggest things for you. And you sort of click on the suggestion instead of having to write it out yourself. And so what they found is really interesting. So comparing the treatment group who have these extra suggestions from, GPT, whatever it was, versus the control group who just had the usual business as usual, is that there was a huge impact on the things they cared about in terms of, problems resolved per hour and how happy customers were, whatever. Huge impact for the lowest skill customer service agents, but basically no impact for the highest skill agents.
Right. So the people who are
really
already
good,
crushing it, didn't benefit that much because they're just good at their jobs.
Because it's like it's suggesting things. Yeah. Exactly. It's suggesting things you were going to do anyway. So like it hasn't helped very much. Whereas if you weren't very good, it's like actually improving what you're doing.
That is a really cool result.
Yeah. So my interpretation of that is that sort of in a world where it's sort of, this is not low skill work, but it's sort of in the grand scheme of the economy, it's like relatively low skilled. And there's a kind of a performance ceiling. There's only so good you can be at, like, the best you can want to do is like you can resolve the problem working with a customer human, right? That's the best you can possibly do. So there's a real performance ceiling here. And like the high skilled are at that ceiling already.
Yeah, right.
And so what GPT-4 is doing, or ChatGPT, or whatever they were using, I'm not sure, is it brings the lower skilled people up to that performance ceiling. That's why there's an impact for the low skill, but not for the high skill. There's another really cool paper that does something quite similar, very different actually, but sort of same sort of theme by, I think, two grad students at MIT, Shaka Noy and Whitney Zhang, who are really awesome. So this other one, they got college-educated professional people, they sort of recruited them on Upwork or somewhere, to complete tasks like sort of writing press releases and writing sort of delicate emails and that kind of thing. So they unfortunately don't have sort of really good measures of prior ability. So for the other paper, they sort of had a huge track record of these customer service agents and like how good they were, like resolved customer problems per hour or something. Whereas for this experiment, they just basically had people self-report, like, how good do you think you are at writing? Like, not very good, quite good, or very good, right? And what they found is interesting, again, like fairly small sample size, but there was basically no clear trend in the benefit of ChatGPT as a function of your prior, at least self-reported ability. So kind of the best people sort of benefited just as much as the least people who sort of thought themselves to be the least good writers.
Right.
So you might think in this case, sort of, writing a press release or writing a dedicated email is kind of, there's not so much of a sort of upper bar on performance.
Right, there isn't the performance ceiling. Yeah, right.
Like you can just keep making that press release better and better and better. At least there's probably some feeling, but it's like it's a bit further ahead.
But it's much higher and fewer people are already right at it. Yeah.
Exactly.
Yeah, that makes sense.
And for the context they were doing it in, like they weren't recruiting, people who were literally the world's best press release writers. Right. They were recruiting sort of random people who happen to be on Upwork, right? So it's sort of, that's an interesting sort of different context. And then the summary of this stuff, I think, is that right now we don't really know. We've got this like really bit of interesting evidence in terms of where there's a performance ceiling, you can really help the low skilled. But, I think there's a lot of anecdotal evidence as well that people who are sort of, really brilliant, particularly in sort of creative tasks, they can like have huge impacts with accessing these models. So taking software developers, for example. So you might think that, it takes someone who can't code, suddenly they can code. That's a massive deal. That's like 0 to 1, right? So that's a huge improvement. But also someone who before, maybe they were designing the architecture, doing sort of very high level sort of senior developer type work. And then they sort of had to have 10 humans actually implementing it. Maybe now it's like, hey, I do that work as a senior person designing the architecture. And now ChatGPT-4, whatever, does all of that work that was done by humans. And so I now, as that senior person, am now like 100x more productive because I'm, I've got the equivalent of like many people's jobs who have now been done for me, and you just need me. You don't need the other people anymore, right? And also worth noting, I guess, sort of separate point, which is that like a 10% increase for a so-called 10x developer, whatever, is a lot more in absolute terms than a 10% increase for a more normal level developer. right? So kind of there's some mechanical sense in which if you're getting a percentage increase in what you're doing, then it's going to kind of the absolute size of that. This is a completely obvious maths point, but just sort of I think it's worth making here.
No, I don't. I don't think it's totally obvious. Yeah.
The size of that is going to be bigger if you're already more highly skilled. If you're getting that same percentage point, kind of like the rich get richer.
Yeah,
and
10 times 10 is bigger than 1 times 10.
Exactly.
Yep. Okay, so just kind of summarize some of these points. I mean, one thing that's standing out to me is just like there aren't uniform effects on different types of skills or different types of jobs. Different kinds of skills and different jobs will actually be hugely differently impacted depending both on like what the skill is and also on like how skilled you are at that skill. And you're just going to get impacts going in all sorts of different directions. Yeah, I guess I did have some simplistic, I don't know, some kinds of people will be unemployed. Some types of people will have their productivity go up. But it sounds like it's just like, I'm picturing like a billion arrows going in different ways.
Yeah, and I think, so we can sort of average out all these effects at the economy level and get something. But absolutely, I think like at the individual task level, and the thing we were talking about in terms of like, are you a low performer or a high performer? Are you a novice or an expert? Like, I'm very skeptical there will be a general answer at that level. Like, you know, for a given task, LLMs help the low skilled more than the high skilled. Like that will not be something one can say about all tasks. It'll be very specific to different tasks, and the economy will sort of be evolving a ton in terms of talking about sort of demand impacts of like when you can de-skill a job, do you want even more of it? Or whatever. There's all kinds of things going on there. There's different incentives for people to use different labor in different ways. And a more general point here actually is wherever there is the most displacement. So suppose it's the case that, you know, middle high school people with college degrees are the ones who are kind of, most of their jobs are being sort of exposed and possibly automated away. That then means that there's now this huge amount of people in the economy with these skills who are like, you know, need something else to do. So if you are an entrepreneur, you have a massive incentive to figure out how to make those people productive. Right, to invent jobs, invent ways of using those people's labor to create value for the specific kinds of skills they can have.
That they can do, but that GPT-4 can't do yet, or something.
Exactly. And that's always a sort of constant dynamic process where you'll create, as soon as there's people out there with sort of certain skills that, you know, right now, those things are being done by GPT-4, but like they are still very skilled people, someone's going to come along and figure out what can we get them to do that is very valuable and will create value. That's true whether we're talking about very, very low school people who, you know, can't read and write, whether it's like very high school people who've got, you know, PhD degrees and yet, you know, the research to be done for them or whatever it is, right? That process is always going to be happening. I think right now there's a sort of, you know, really interesting point where it's like, in a sense, GPT, like what GPT-4 or whatever can do, like that's now the baseline. So like as a human, what can you add on top? Right? And so it's like, what are you adding on top? You can imagine, so here's a thought about software engineering, right? You can imagine this kind of sort of hollowing out the middle of software engineering. You can imagine where suddenly it's possible for much lower skilled people with less training, less experience to create the kind of software that took a person who was on, you know, £150,000 a year before, right? And you sort of suddenly, the thing that's a bottleneck that the humans are actually doing is like they have the context. They've done the user interviews to figure out what we should build next, right? But then the skill of actually writing the code is done by the algorithm for the most part, and they're just sort of making sure the tests are the right tests and things are working as they're supposed to do and whatever, right? So you've really de-skilled that, and now you have like many more people who need much less training to do that kind of software engineering. But then at the other end, you might say there's also a different kind of people who like, you know, add a ton of value on top of what GPT-4 can do, because maybe right now GPT-4, you know, it can only reason about a code base of a certain size, and it doesn't know everything about sort of exactly what cluster setup you've got, whatever. And so you're having sort of that kind of architectural thinking, or slash, you know, all the sort of the managing of all these lower skill humans needs lots of people skills, slash the interaction with the sort of the business side of the company, and what their objectives are, and sort of translating that into the traditional sort of product manager type skills. So you can imagine all those kind of things being like more high end now, and like you're adding a ton on top of GPT-4 there. And so that suggests a kind of there's more low skill demand and more high skill demand of a slightly different kind. And I think you'll see something like that everywhere. And the sort of one of the key questions is like, if you're good and you can use GPT-4, like what can you use like 1,000 assistants who are better than you at the thing you currently do? Like how would you orchestrate them? And if you can do that, you're now very productive. And like the skill of orchestration is kind of the hard and difficult thing. And you're doing that. And that's going to be, really, really valuable.
Very valuable. These feel like ways that the economy is going to like smooth things out in the labor market. Are there any other kind of effects like that you expect to see?
So I think there's one kind of more macro thing, which is kind of very much sort of more historical, which is to do with the overall pattern of inequality over time. You might think a technology comes along and the technology, it can do either one or two things. It can increase inequality or it can decrease inequality. And what the historical record suggests is that it's not as simple as that. And the same technology over time can, increase at one point and then decrease at another. So there's this brilliant work.
Do we have an example of that?
Yeah. So, well, it's not a specific, it's not so much like one technology. It's more sort of the Industrial Revolution, I think, in Britain in the 19th century. So there's an economist called Robert Allen, who wrote a very famous paper called Engels' Pause a few years ago, 2009. And he makes the point, he's an economic historian and lots of very careful measurement, basically showing that inequality increased a lot, and kind of workers kind of lost out sort of the share of national income that was being captured by people doing wage paying work, laborers, kind of really went down over time, and the sort of the share of the output that went to sort of the owners of capital went up. But then at some point that reversed and inequality decreased a lot. And sort of the workers sort of caught up. And one story for what's going on there is, at the beginning of a sort of period of vast technological change and automation, and there's like lots of sort of adoption going on. Like, what concretely is adoption? It is companies investing money in order to change their production processes and figure out how to use this new technology, and then actually paying the money to get it, right? Sort of buying the new equipment or the software subscriptions or whatever it is.
Sure.
And so at that moment, suddenly capital, which is to say sort of, people who've got spare money sloshing around that then can be invested. So, companies will borrow money or they will, issue stock to raise money or whatever it is. That is suddenly becomes really in high demand. And sort of because you invest capital and you get these wonderful returns on the capital because you're now doing this huge amount of automation, whatever it is. And so those gains flow a bit more towards the people who have the capital because sort of the thing that is scarce, the relatively more scarce and more important is the capital because it's like really expensive to do automation and there's like these huge gains to be had from automating, and therefore the people who sort of have the scarce resource, which at this point is sort of money floating around, the spare cash to invest, they get the benefit of that. But then over time, you finish doing all of that, capital suddenly becomes sort of less scarce, the automation, all that stuff's been done. And at the same time, all these entrepreneurs have come along and figured out, we've got all these machines doing this other stuff. Like, I figured out some ways of now making, in this newer world, making workers more productive.
Yeah, right.
And if they're more productive, they're going to get paid more under sort of standard conditions. And so that means that workers then now start getting paid more and the economy sort of rebalances and readjusts and you're sort of back to where you started almost in terms of inequality. And this, by the way, is over like, I don't know, a 50, 100 year period. So these are like very, very long-term historical stuff.
Longer run effects. Yep.
Yes. And so I would not be surprised if we saw something similar today with AI, and maybe it'll happen faster, but I think it's quite possible you'll see something similar.
Cool. So I want to move on a bit and get into some of the specifics about the shortest term. So what might happen while AI systems are, increasingly capable, but before we have AGI? We don't know how long that will be. Maybe it's just the next few years. Maybe it's 5 to 10 years. Maybe it's longer. But I'm interested in this partly because, for one, it's easier to make predictions in the near term, and especially when the state of the world will more closely mirror things that we've seen before. But also just because even if the world might look really crazy once we get to AGI, I'm still personally very curious about what the transition is going to look like. There's this thing I'm often tempted to do, which is just like, imagine what the world's going to look like when we have AGI. Like, that could be insane. But like, if you took that away and assumed that AI's abilities would be capped before AGI, things are still going to be really remarkable and different. And I feel like it's easy to ignore that, like, just very soon those things will start to impact our daily lives. I mean, they clearly already have, but probably more and more. And so I want to spend some time focusing on that.
Just to say first, like, I completely agree that I think if we stopped all development of bigger language models today, right? So GPT-4 and Claude, whatever, they're the last things that we train at that size. So we're allowing lots more sort of iteration on things of that size and all kinds of fine tuning, whatever, but like sort of nothing bigger than that, right? No sort of bigger advancements. Just that, what we have today, I think is enough to power, 20, 30 years of, incredible economic growth. I think it's sort of, this is certainly
huge.
Feels like as big as the internet, right? Already, like,
right.
easily.
Cool. Okay, that actually is a really helpful comparison.
So yes, we're already in an exciting place. Yeah.
Great. I'm glad we're on the same page about that. And actually, I wasn't totally sure we would be, and I trust your judgment on it more than mine as the labor economist. But yeah, I guess to get really concrete about what that's going to look like, it seems, I guess, intuitively obvious to lots of people that if a technology like this suddenly comes along and it can do lots of jobs better than humans can, then the people who had those jobs are going to find themselves unemployed very quickly. So I'm curious. I think actually that story is like at least maybe wrong, despite the fact that it's kind of a natural thing to think. So I wanted you to tell me why that's wrong. Or at least why it might be.
Yeah. So I think there are lots of different ways that it can be wrong, and those ways are all like really interesting. So we should sort of spend some time talking about them in a bit of detail.
Great.
So there's a few sort of buckets of explanation or sort of conceptual points to make here. The first one is around this idea that, if some jobs get replaced by technology, then the people who did those jobs, they are just thrown on the human slag heap and there was nothing for them to do and we're all like immiserated and, isn't that terrible? And all we need is we need to urgently move to, a UBI system or whatever it is, right? But sort of here is the story as to sort of why that is not necessarily true and why the history of the last, I guess the entire economic history pretty much of humanity so far, that hasn't happened. Why is it? So the first point to make is, let's take the following scenario. So right now, we all spend a decent chunk of our income on food, let's say, right? Let's take food. Think about food that you sort of go and buy in the grocery store. So maybe every week you go and do your weekly shop, right? And maybe you spend £50, maybe spend £100, who knows, right? And so over the course of a month, maybe you're spending, I don't know, £300 or £400, right, on groceries. Let's say it's £400. So now suddenly suppose that some amazing automation technology comes along, and all those people who were, driving tractors and managing farms and driving lorries that, move things around the country and around the world, and, all the people working in food processing plants and, all those things, right? They're all fully automated just tomorrow. It's amazing. And those jobs have all gone. And it's all done by these incredibly much cheaper, robots and algorithms and who knows what. So there's all kinds of clever vertical farming going on, you name it, right? And suddenly that means that the actual cost of producing this stuff, before you were paying all these salaries to these humans, and now the LLMs are doing it for free, or virtually for free, right? So what was your shop of £400, right? Maybe now it's gone down and it's £50. Right, so like this is obviously a sort of silly accelerated example, but sort of
sure.
Suppose that's the case, right? You did a huge automation, and you've now everyone in the country, they were all spending £400, now it's £50. So what does this mean? So okay, on the one side we've got a bunch of people who are now don't have jobs apparently, right? Sort of all the farmers and the tractor drivers and the food processing workers and so on, and also, though, every single person in the economy has now got an extra £350 per month in their pocket. Right? So their jobs haven't changed, right? Everyone else in the economy is doing the same as before. Everything else is like, the only thing that's changed is now food is cheaper. So you've all now got an extra £350 per month in your pocket. So what do? Well, You tell me, I guess. So what would you do?
I want more other things.
Okay.
I probably don't want more food because probably I'm eating enough food. But I probably want to spend that $350 on, I don't know, a nicer flat. Or actually, maybe I want to donate. That'd probably be good. But still, I probably want things that other people could create for me with that more, additional money.
Right,
yeah.
Exactly. So let's just go through those examples, right? So you said, we said probably not food. So I actually suspect that you might actually want more food, but you go for fancier food. So you would now go to restaurants much more.
Sure.
Right?
Yeah. Yeah, that sounds right.
And the restaurants are now going to be, kind of what you're paying for is the fact there's a wonderful chef who, is from a certain town in Italy who sort of hand rolls the pasta every morning. And so you're sort of paying for actually a much more human intensive form of food than what you're getting in Tesco or whatever, right? Or maybe you are saying, you know what, I'm going to work on my mental health. And I was just paying £10 a month for a Headspace subscription, but now with an extra £350 a month, I can afford a therapist.
Two therapists.
Two therapists. And so, again, that's, now extra demand for new jobs that didn't exist before. Now, a couple of other things that are a bit different, right? So, you mentioned, funny enough, you said, I might get a better flat, right? So that's really interesting because flats are these inanimate objects, right? There's no sort of labor involved in sort of a flat sort of continuing to exist. And they just sort of exist and sort of sit there. And in a world where, we probably won't get into sort of the housing theory of everything on this podcast, but sort of there's a whole bunch of important things to say about the way that land and housing is this like really important weird thing in the economy that explains lots of other things. And the way that's coming up right now is the fact that if everyone suddenly starts saying, I've got my £350, I'm going to spend on a better flat. If everyone thinks that, right, then all that happens is the price of flats go up. Like you're in the same flat, just now you're paying more for it, right? And so what's happened is, so where's that money actually go? Well, it goes to your landlord or your landlady. So what's happened is that there's basically been a wealth transfer, a resource transfer to people who own these assets. So there's been asset price, what economists would call asset price inflation, right? And these landlords and landladies now, I guess they're the ones who are spending the extra money. So it's their, do they want to go to fancier restaurants or whatever it is, right? But it's still the case that someone is spending the money somewhere. And the funner thing you might do, by the way, if you have an extra £350 per month, depending on, how old you are and maybe your preferences over leisure and labor and so on, is that you might say, you know what, I'm going to work fewer hours because...
Yeah, that sounds great.
I'd rather have the extra day off a week or whatever it is, right? And so if you're not saying, oh, you know what, I'm going to work fewer hours, and like if everyone does that, then suddenly... well, there's now a whole, that extra day that you were working, someone has to work that day now. So again, you've created extra demand for labor. And so this is happening, everywhere in the economy in this sort of automation scenario, right? And so what's happened is this particular bit of the economy has been automated, wonderfully more productive, amazing, but, also these jobs have disappeared. But the sort of what cannot help but happen at the same time, it's like an iron law of economics, the money that everyone's making has to go somewhere, and it goes on basically empirically, historically, where that ends up going is towards goods and services that are more human labor intensive. So you're actually creating more jobs directly. So it's this kind of feedback loop in the economy that is, a really, really important first order thing that happens when you have these kind of productivity increases. And because humans and indeed houses, to your point about flats, because these are the things that are scarce.
Yep.
The LLMs, there's, unlimited quantities of them. We're the things that are scarce. So, sort of law of supply and demand, the thing that is, in sort of limited supply, the price goes up, right?
Right.
And so that's the thing where, suddenly all of our wages go up a bit and everyone's got more stuff. So that's that's like the good story, right? That's broadly what has happened over the last 200 years. That's why we are all in these weird jobs that did not exist 200 years ago, and we're all much, healthier and hopefully happier.
Right. I don't think I fully internalized the extent to which this does just happen constantly and has happened over the past few centuries. And obviously we're not doing the same jobs as people were doing 200 years ago. For example, a fact that I read was something like 60% of the jobs that exist on the US labor census today didn't exist something like, 60 or 80 years ago. The exact numbers are probably wrong, but it's something like that. And that's pointing at this general thing happening loads in a way that is just really not obvious to me unless I think about it. I guess this AI case seems different in that it might happen even faster. And the amount of automation that's possible might be more extreme. But at least at least for now, when we're talking about can automate some tasks, but not the vast majority of them, it does seem like if you look back historically, the kind of thing that happens is this shift to an economy that, where people are doing different sorts of jobs over time, and not one where there's mass unemployment. Yeah, am I getting that picture kind of right?
Exactly. Yeah.
Cool.
And the reason that happens is because as things get automated, the amount of goods being produced in the economy, are going up almost by definition. If they weren't going up, why would you automate it? And so you've goods about going up and so does human labor and demand for that labor because people can afford to spend.
Right.
And so they end up getting allocated to, ever more productive or useful uses that serve human needs. And to your point around, this happening for a long time. So my favorite example is, again, I guess I started with agriculture and food, right? So let's think about agriculture. In US example, in 1790 in America, 90% of jobs in the economy were on farms. 90%.
Right.
Today it's 1.7%. And it's amazing if you look at the graph of this, on the x-axis you've got time and the y-axis you've got percent of jobs that are on farms. It's a surprisingly linear. It's a straight line from 90% in 1790 to close to, 2 or 3% in about 1960. And then it's it can't go much below that from that point to today. So it tells a bit, but it's very, very linear, and very steady and very slow.
Yeah, I think in my head it was something decreased a lot at once as new technology, a couple of important new technologies were introduced, and then that automated a bunch of tasks away, and then those jobs stopped really existing, and those people kind of moved on to other things slowly.
Yeah.
But I guess if it's linear, I don't know. I guess it makes me wonder if the whole process is actually just smoother than I'd imagine.
Yeah.
Okay, so you said there were a couple of things that can happen that mean we don't necessarily get mass unemployment. And it sounds like this is one, the economy kind of shifting in response to these changes in the availability of certain kinds of labor. What are other kinds of things that can mean that you don't get this extreme unemployment effect?
Great. So that first thing was a kind of very macro, this sector of the economy has no humans anymore, and those humans all end up doing other things in other sectors of the economy, and possibly new ones as well. So a second thing is, okay, but let's still just look at this one sector that's getting automated and think about whether it really is the case that when you have big automation in the sector, the number of humans go down. Again, that's intuitive, right?
Sure.
Automation means fewer humans. Done. Turns out it's not that simple. And so there's a few examples I guess I'll start with, then we can talk about what the broader lesson is. So here is one example. I think this is due to Jim Besson, who's an economist, who studied ATMs. So ATMs, where you cash machines, right? You go to a bank branch and get cash out. So before ATMs, there were individual humans in the bank who would you'd go up to them and show some ID and get your account details, and they would give you some cash, right? And bank tellers, I think they were called. And you would think, right, ATM comes along, that's it for those people. No more bank tellers, huge declines in employment in the banking sector.
Right.
And what in fact happened is something quite different. So the ATM did indeed reduce the number of people doing that specific task of handing out money, right? But of course, there are other things people do in bank branches as well. The big thing that happened is that because a given bank branch no longer needed to have all these very expensive humans, doing the cash handing out, it became much cheaper to open bank branches. And so, whereas before there were only bank branches perhaps in, the larger towns, whatever, suddenly banks were competing to open branches everywhere because the more you can, go into the smaller and smaller towns and whatever, villages, who knows, you can, have more customers and provide a better service and so on, right? And so what happened was the ATM meant there were fewer staff per bank branch, but enabled the opening of many more bank branches overall. And that actually offset the first impact, right? So fewer staff per bank branch, but so many more bank branches that the total number of people in bank branches actually went up, right? What they were doing was quite different. The humans now are doing more higher value add activities. They're not handing out cash. They are doing other kinds of services. But, similar people doing a similar-ish job. And there's actually more of them now, right? And so the fancy economist way of putting this is you have a demand elasticity in the presence of complementarity. So those are crazy, silly words, but this is kind of what I mean.
Yep.
So demand elasticity means when you reduce the price of something, you actually want more of it. So automation generally brings the cost of things down. But what normally happens is you just like, great, I have the same amount of stuff. You say, no, I want more of that stuff now. Give me more. Then in the presence of complementarity, that means that, so complementary, we think of, if humans are complementary to the automation, the technology, whatever it is, in some way, right, there's still some humans involved, like fewer than before per unit of output, but still some.
Sure.
Then, because people now want more and more of this stuff, it's sort of each unit of the thing is more automated, but there's still some humans involved, and therefore you end up possibly having ever more humans totally demanded, doing slightly different things, but still roughly in the same ballpark. Does that make sense?
Yeah, no, that makes perfect sense.
Okay, here's another historical but somewhat more recent example that I think illustrates this point really interestingly. So let's think about computers, and think about computers in, I think, the 1980s. So in the 1980s, as I guess at many points in history, Britain was really worried about its productivity. And it was particularly worried about its productivity compared to other countries. And at a certain point in the 1980s, it was very worried about compared to Germany, because Germany has like way better manufacturing and so on. And we were like, why are we so rubbish at this? And so there was commissioned a series of studies by NISA, which is the National Institute for Economic and Social Research. And they did a bunch of really fun studies. So they sort of sent a team to go and look at exactly what was happening inside a set of matched plants. So you'd find like a furniture manufacturing company in Germany and one making the exact same or similar product in the UK. You go and visit both of them and say, like, what is the same, what is different about these two plants? And do that for a bunch of different areas. And okay, so they were kind of like, basically it turned out that in every possible industry they looked into manufacturing, Germany is more efficient. And they were like, well, let's try hotels. Maybe in the service industry, Britain is better. But hotels and same thing was true, Germany is much better at hotels. And there's a particular, like, it's almost a throwaway anecdote that I think is really interesting about hotels in Germany in the 1980s from this study, which is that they were looking at the use of technology in lots of different areas, throughout these studies. And they were looking at, in particular, then the use of computers in hotels. And there's sort of a very striking conclusion they had, which was that in the UK, sort of hotel managers saw computers as a way to keep the quality of service the same, but be able to employ a less skilled person to provide that service, right? So it's like, before you had to be able to, I don't know, read and write really carefully and manage records and whatever, and now all you have to do is like, press a couple of buttons on a computer. So, right, okay, so you're basically reducing the cost of the labor. In Germany, however, they were like, no. We can use computers to have the same humans, but now providing a much higher quality of service. And so you sort of generally have, you always have these options as a person, running a company, and which you will choose will depend on all kinds of interesting strategic factors. So thinking, I guess, ahead now about automation, I'll give you two sort of contrasting examples. So supposing that GPT-4, whatever, makes salespeople much more productive. So now, your salesperson, one salesperson would bring in, £10,000 of sales, and now they bring in, £50,000 of sales. If you're sort of the CEO of this company, are you like, great, I can keep revenue the same and cut my sales force by 5 times? Or do you say, I'm going to 5x my revenue? I'm pretty sure most people would choose to 5x their revenue, right? So that's a case where sort of the elasticity works such that you're like, great, give me more, right? It's cheaper, so give me more. However, think of another example. Suppose you are one of those, private equity owned care homes, right? They buy a care home, they sort of try and cut costs and, make them more efficient from a sort of capital point of view. Perhaps with sort of, not entirely full regard for some of the people living in these homes, the sort of, the elderly people living in them. And you're like, okay, supposing that as of now, GPT-4 can in some way make nurses twice as productive. So maybe it does all of the prescribing and all the sort of admin type tasks that nurses have to do. What does the manager of the care home do? Do they say, great, I can now keep all the nurses and they can spend much more time with patients? Or do you say, great, I can fire half the nurses and provide the same quality of care? Probably, at least some care homes are going to do the second thing, right? And so I guess the broader point here is that sort of it can go either way. And generally you'll have, some companies that choose to prioritize quality and compete on quality, and others which choose to prioritize cost and compete on lowering costs. And both those things can happen at the same time in the same industry with different companies, right?
Yep. Yeah, that makes tons of sense. Really, really good examples. Yeah. Was there another, kind of effect that's not just like unemployment that you wanted to talk about?
So the final thing I think is really interesting to think about, and is often not intuitive, is thinking about the impacts on individuals, right? So we've accepted that there definitely could be some individuals who are, whose jobs existed and then they disappear because they're being automated. Nothing I've said so far is saying that doesn't happen. That certainly happens a ton, right? And I've given you some examples of why we shouldn't worry so much perhaps about it, because there's more demand in other bits of the economy, whatever. But what does that look like for the actual person experiencing it? And is it good or bad? And, when is it good or bad? And so there's a couple of really interesting facts about the way things kind of work in the economy that I think are worth touching on briefly. So the first one is that there is this not very nice term, but it has a benign consequence. So the term is natural wastage. So if you're a company and you're hiring people, so let's say you're McDonald's, right? And you're McDonald's and people sort of leave, their average tenure is they start working for you and 6 months later they leave and go and get a better job, right? Yep. So that sort of half of people leave within 6 months, whatever, that's called natural wastage. People are sort of naturally leaving. And you would include people retiring and whatever as well as part of that. Also natural churn. So that means there's this sort of very natural attrition happening in all companies all the time. And so supposing, let's take McDonald's as an example. So if McDonald's somehow automated everything, like the burger flipping and the cashiers, and they've been trying for a long time, right? They're sort of slowly happening, but there's still some humans there right now. Supposing they did it, right? All they would have to do is stop hiring any new people, right? And within a year, they would just have no employees, because just within a year, everyone naturally leaves and goes and get a better job anyway. That generally is what happens. Right. So the average tenure is 6 months at McDonald's. Okay. So you just sit and wait, and everyone goes of their own accord. No firing required, no displacement required, right? And so you see this happening at a sort of much more macro level in a really interesting way. So one study that I did a while ago was looking at manufacturing workers in the UK between about 1990 and 2010, I guess, and looking at what happened at this time when there was a huge reduction in manufacturing employment in the UK as a sort of result of a few different factors. I think the biggest ones are trade, so China's producing the same stuff that we're producing but cheaper, and then also automation. There's a lot of automation happening as well, of different kinds. And what's really interesting is if you look at the age profiles of who is working in manufacturing, and ideally you would sort of trace individuals over time, which I was doing a bit of in some other areas. Cool. And what happens was really interesting. Okay, so here's sort of some astonishing facts. I don't know, these numbers could be slightly off. I'm remembering them as it was a while ago, but they're sort of directionally correct.
Sure.
So the number of people who are age 60, or let's say 55. Okay, so people are age 55 working in manufacturing in the UK. So let's say 1990, number of 55-year-olds working in manufacturing compared to 2010, number of 55-year-olds in manufacturing. At this time when the total number of people manufacturing is maybe it's going down by some enormous percentage. I forget exactly what, right? But it's huge declines. The number of 55-year-olds actually goes up over this time period. It increases. The number of 25-year-olds goes down 90%.
Wild. Okay.
Right? So you see what's happening there?
Can I actually just guess what's happening?
Yes.
Yeah.
Tell me.
Okay, so it's something like people that are kind of young and deciding what field to enter are I'm not going to enter that one. That's a dying industry. There's a bunch of manufacturing. China's doing it. That seems dumb. I'm going to go into something else. And then older people that were already in the industry, they've got loads of career capital there. They're good at their jobs and they keep doing it. And they end up being kind of a larger proportion of the share of workers in that field as they get older. So fewer people enter, but they just stay in it and do a bigger proportion of the jobs available. Is it something like that?
That is exactly it. Exactly that.
Cool.
Right? And it makes a ton of sense, right? Because if you're sort of the mastermind organizing the economy and sort of allocating people to different jobs, obviously that's not what's happening, but if you were the mastermind, it would naturally be the right thing to say, no, people who've got all the human capital and they've worked in the industry and they're going to find it really hard to move, let them keep the jobs. And then the young people, they shouldn't get into it because that's a bad bet for the long run. They should do something else, right? And obviously, people sort of make those decisions for themselves and that's what happens.
Yep.
So you have these, really, really interesting effects of that kind. The same thing, by the way, happened. So we talked a little earlier about farm jobs in the US, right? And one thing I've done is I've kind of plotted, so you can really, it's amazing, you can link people over time in the census. So every 10 years there's a census, they sort of count every person in the entire economy. This goes back, hundreds of years, and you can link people over time, and you can also see their occupation. And so you can see, who is kind of staying in being a farmer, who is leaving, right? And what's happening is, if you trace, so at this time over, more than 200 years, where people are, the percent of people working in farms goes from 90% to whatever, 1%. Over that time period, every single cohort of people, are you sort of just, people who are born and start working, the percent of a given cohort working in farming only ever goes up its entire time period. People sort of start working in farming, and they live their careers there, and they're happy, right? And so fewer people start every single decade, but people who are sort of still in it, they stay in it. So this happens in this huge long macro timescale. And so to again bring it to the future, or think about the future, who today is thinking, I think being a taxi driver is going to be a great plan in a world of self-driving cars, right? Probably not, fewer people today are thinking that than 20 years ago. Or who's thinking, I know, suddenly all the press, 5 years ago about radiologists being automated. Who's thinking, for my medical specialty, I want to be a radiologist. Now, the really cool, ironic, interesting thing about this is that this can have this really funny short-term effect where the technology is promised. Everyone updates to say, oh, these jobs aren't going to be there anymore. But it takes longer than expected, and so people stop moving into the field, but it hasn't been automated yet, which means that actually wages go up for that field.
There ends up being like a shortage. Oh, wow.
Yes, and there is right now, I believe, last time I looked into this, there's a shortage of radiologists. And I'm sure there's many reasons for it, but one, very interesting story you could tell is people are forward looking, why should I go into this? But it hasn't actually been automated yet, so there was a shortage of humans. So the big macro thing is that. So older people stay in, young people sort of move and do different things. That's by far the most important individual level effect. So those are two very rosy pictures I just painted for you, right? And so the final thing on this point, sort of the third point, which is a less rosy one.
That was sounding a bit too good to be true.
Yeah, so I think most of what I just said, that is true. Like this is what happens. This is sort of the majority of what happens in the economy, and it's why people generally have, they have jobs, and they get paid more over time for in their work. Now, where does that go wrong? It generally goes wrong in a couple of sort of circumstances. Namely, it's very inflected by geography. So what we know in terms of where can you go and see people who have actually really been hurt by a automation technology coming along, or maybe a other kind of, so trade as a big example, China comes along, suddenly makes things cheaper. If you are a young person in a big city and you were doing some job, then that job goes away, whatever.
Loads of other jobs. Yep.
Fine. You go in loads of other options, go and do something else. If you are a older person who's been at a particular firm for a very long time in a town where that firm is the only large employer and there is no other industry in that town, and also you've got this amazing union job, your wages are really high because of decades of strong worker empowerment and so on, and then that company goes away from that town.
Yep. That
is not a good place to be, because empirically people turn out to be stuck in their towns, right? They just don't like moving. And if you're in your whatever age, 40s, 50s, got a family,
kids are in school,
and your job goes away,
own your house.
Exactly, in school. Yeah, it's your house is now worth nothing, so you can't, because there's no jobs anymore. So you can't sort of sell up and move somewhere else. That's really hard. You can't sort of sell your cheap house and move to a much more expensive house in a city somewhere else, right? Your kids are in school, as you're saying, etc., etc. So what you see is people they kind of get stuck, and there is no job of any comparable quality that they can do. And so there's, on average, when you have these sort of big plant closures, people do tend to go and get other jobs, but they often experience big wage declines, 25% sort of enduring wage decline. That's not nice. That's really horrible.
Yeah.
That's a really horrible thing to happen to someone.
Yeah.
And that can happen, that sort of happens to large numbers of people at the same time in these sort of geographically concentrated ways. That's where things get bad. And so, like, if you're young in a city, you're kind of fine. If you're older, or, sort of mid-career older in a small town with a single employer, and that's the thing that gets automated, that's when things look much less rosy.
That can be terrible. Yeah. And I guess I do feel like those stories come to mind for me more than the other stories. I guess just because they'll be newsworthy. Like,
person leaves job, gets other job. It's like no headline there, right?
Yeah, exactly.
Yeah. And by the way, so an interesting thing, here's my, I guess, natural optimism coming through quickly on this point, which is that thinking about large language models in particular, right? Like, what they automate is generally cognitive tasks. And cognitive tasks, I've not actually looked into this carefully, but my strong hunch is that they tend to be clustered in cities. Well, I guess you find some examples of like a call center that is placed in some kind of, random middle of nowhere city, because there's, lots of sort of cheap labor and not many other options there.
Yep.
Do you see bits of that? But it feels like sort of it's a bit less common than these sort of previous cases where it's like a particular factory that made something, and like it was in this village it was a coal mine, and like it was there because that's where the coal was. I think today there's like ever more, urban agglomeration and so on.
Yep, that makes sense. So some foreshadowing about the fact that AI might have different kinds of effects than technologies that have been worse for people who couldn't move. How quickly do these adjustments typically happen? Because I'm wondering if one of the reasons that it's, so smooth in many of these cases is because, technology gets rolled out slowly. Whereas in the case of AI, the rate at which AI might automate different tasks seems pretty quick. Plus, AI seems to me like the kind of technology that doesn't intuitively require a bunch of physical infrastructure to be built. So I don't know, like the way banks and ATMs did. Does that mean that, these adjustments where people go find other jobs just won't happen quickly enough or keep pace?
Awesome. So I think maybe the right way to approach this question is we can start by very quickly talking about what's the baseline? Like, how long do these things take for other technologies that were as big as AI seems to will be? And then we can talk about, okay, why might AI be different? And what will be the same?
Yep.
Right? Okay. So the two big examples that are, I guess, everyone's favorite are sort of IT, sort of computers in general, and then electricity. So these are probably the two biggest general purpose technologies of the last, certainly, 150 years. So how long did they take? Well, there's an astonishing sort of regularity in how long these things took. So if you date the arrival of electrification to 1894, which is the time people, economists who study this, tend to use, I think it's a couple of years after the first sort of proper power station was built.
Okay.
And if you date IT to 1971, I'm not sure why economists use that date. Maybe it was when, I don't know, some sort of IBM mainframe properly came online or something. I'm not sure.
Sure.
Anyway, so those are the dates people seem to use in economics, right? And if you plot if the x-axis is sort of years following the arrival of IT or electrification, and then the y-axis is percent of adoption that's happened. So 0%, no one has it. 100%, now everyone has it, right?
Yeah.
It turns out those two lines sit exactly on top of each other. So IT diffused basically as fast as electricity. So it's a point one, surprising fact number one is that these things that were 100 years apart almost took as long as each other, even though you might expect things to sort of be moving faster later in history. And the second interesting fact is that it took a long time. So it took 30 years to get to 50% adoption.
Yeah, that is much slower than I would have guessed, I think.
Yeah. And these things just move really, really slowly. And this is true both for sort of households adopting technology or getting access to these technologies, and also for industry.
Uh-huh.
And so we can tell you all kinds of interesting things about sort of how long it took. So one sort of, I guess, final quick interesting fact. So if you think about all technology and capital in the economy, so I guess take the US, right? So think of every bit of factory equipment and every computer and everything you might think of broadly as technology, capital, equipment type stuff, right? The time, so starting in sort of 1970. So 1970, there was basically, close enough 0% of the capital stock consisted of software and computer equipment, computer hardware, hardware and software. In 1990, it had only got to about 2%. And then by 2000, it had got to 8%. So, and the real inflection is sort of about 1995, if you sort of look at the graph. But the point is, there were sort of, there were 2.5 decades of like actually very, very slow, where everyone thought like, right, this is it, we're here, IT era,
right,
go. And 25 years later, nothing to see, and only right, after 30 years do you sort of see a real increase. And even then, right, so even in 2000, only 8% of the capital stock consists of computer software and equipment.
Yeah, and was most of the thing happening in that early period, like the technology improving, or was it just like the technology being incorporated into the world and like, the world catching up in various different ways took that long?
Very much both. Very much both.
Oh, okay.
But think about technology in the 70s, right? So compared to like 1990s, like the IT was getting ever more user-friendly, ever cheaper. Moore's law was happening all through this time, right? So you wait a few years, it gets twice as fast and half as expensive.
Right.
So that's happening, and people just wait a long time to get to the point where it's actually worth adopting. And it takes a long time for sort of companies to adjust all their operations to make good use of this stuff, right? And we'll say more about that in a second when we sort of think about LLMs. Another example, actually, which is interesting, is the automation of the sort of the telephone system.
Uh-huh.
So do you remember, like, you've seen these photographs of, like, generally women sitting in front of these huge panels and, like, connecting calls, right? Plugging different calls between different numbers.
Yep.
So the automated version of that was invented in 1892. Okay. However, the number of sort of human manual operators peaked in 1920, so 30 years after this, at which point AT&T, which is like the monopoly provider of this, is the largest employer in the US, right? They are the largest single employer in America. 30 years after they've invented the complete automation of this thing that they're employing people to do. And the last person who is a manual switcher does not sort of, lose their job, as it were. That job doesn't stop existing until, I think it's like 1980. So it takes 90 years from the invention of full automation to the sort of full adoption of it in a single company that's a monopoly provider and can, it sort of is in charge of, can do what it wants, basically, right? And so the question perhaps you might have is like, why on earth?
Yeah, what the heck? Why is that happening? Why is it taking 90 years?
So it's to do with a few things. So one is the extent to which when you start using humans in the system, you build everything else around the humans. And so the humans are generally doing a sort of a bundle of different tasks. And the switching is kind of the most important one, but it's one among many. And you end up having to sort of do a ton more sort of corporate process reorganization to be able to do the automation. And that takes a long time to unwind yourself from the world where everything goes to this human, because there's many more things happening than just a switch that's been switched. And then the second thing is that, so this is, both of these are very generally applicable. Second thing is that it costs money to switch from a manual exchange to an automatic one. And, money isn't free. And if you're a company, you are going to make investments that, make economic sense and not do the ones that don't make economic sense. So the way it worked in the case of AT&T was in the really big cities, think about this, there's a fixed cost of automating any particular telephone exchange. The exchanges, are physically located in different places. The telephone exchange in a city is going to have, thousands and hundreds of thousands of wires coming into it, right? And so it's like, by switching that to automated, you save loads of humans. Whereas all these different exchanges in the middle of nowhere, like in much of rural areas, right, they might only have one human. You don't save much by switching, but the cost of doing all that change and equipment is actually still really high. There's a huge fixed cost, and so you don't bother doing it until you really, really, really have to. And so if you look at the history of AT&T, they started by automating these big cities, and the very last thing to be switched over to sort of from human to automated was this, like, I think it was on some island somewhere, like a tiny population. It was just like the last thing that was worth doing.
Right, that makes sense.
Right? And so this is, I guess, sort of a good, interesting segue into sort of, why large language models and AI in general might be the same or might be different.
Great. Let's start with the ways they might be different, and we'll come back to the ways in which they're actually similar.
So how might this new, breed of language models and AI in general be different in terms of how long it takes the economy to adopt them and what that means for the economy and people's jobs? So I think the first really interesting thing is that these large language models are general purpose, like from day one. So, you train GPT-3, GPT-4, Claude, whatever, and out of the box, it can do marketing, it can do writing emails, it can do science, it can do everything, right?
Coding, yep.
Coding, yeah, 100%. And generally in history, so like, the PC, when the PC first came into existence, it could do, there was one killer app. Which, do you know what the killer app was for the PC? Because it's a fun bit of trivia.
I don't, and I'm actually surprised you used this example because I would have thought they were more general purpose. But what was the killer app?
So they are general purpose in terms of in theory, they can do many things. But when they're first created by their creators, in quotes, there's only going to be so many apps, right? And so think about, I guess, quick side note, the iPhone, when it first shipped in whenever it was, 2007, was it? There was no app store, right? And it had a calculator, and you could had visual voicemail or whatever. Couldn't do that much other stuff.
Sure.
Stuff the internet, that was a big deal, I guess. It was only a few years later when suddenly it could do literally anything you could think of, and there were thousands, millions of apps on the app store that it became this very general purpose thing. The iPhone hadn't changed very much. What had changed was the number of applications that had been built on top. And so the same thing was true with the PC. So the PC, when it's, was first kind of, quote, invented, is this huge box, whatever, and it was very expensive. And why would you want one? What would you do with it? There's no internet back then, whatever, in the 70s. And so the first app actually was VisiCalc, which is it was the first spreadsheet app, as far as I know. And so people who are going to bother to spend lots of money on a computer, because I guess you had a typewriter existed, right? So the word processor is not that much on top of a typewriter. This is a much bigger, fancier, cooler, newer thing. Exactly. So 1979, VisiCalc is launched for the Apple II.
Okay.
Which is this, one of the very early Apple computers. And that was the reason a bunch of people first bought computers, was to use VisiCalc.
Huh.
And it took an absolutely, a ton of time before, everyone wanted to have one, because you could watch movies on it, or everyone had to have email or whatever it is, right? So it just takes a really long time to figure out how to get the most out of the general purposeness of it.
Right. And I guess that's taking years in these cases.
Decades in these cases. Before LLMs came along, AI was pretty similar, because to make it useful, you had to go and collect all your training data, and for a very specific application of recommending YouTube videos, or text to speech.
Right. Or AlphaFold, protein folding. It's just that, and it's exceptionally good at just that, but just
exactly.
That. Yep.
Yes, and it takes a ton of time and effort and risk and money and expense to make each single application, right? Even though in principle it can do many things. So what's different about LLMs is because they trained it on everything, as it were. They put the entire internet and who knows what else in the training data. Out of the box, it can do all these different things. It's kind of much, much, much quicker and less expensive to get it to do different things. All you have to do with your limit is only your imagination of what you might ask it.
Creativity.
Right? So that's the first reason that this time is different, I think. It's so much more capable and useful out of the box at so many different things.
Yeah, it does seem like people are taking some time to figure out that you can plug it into all of these other apps like calculators. But it's happening over the course of months, not decades.
Yes, and the way that you figure out whether it can do something is you open up GPT-4 and you type in the prompt and you spend 0.04 cents.
Right. And it's I kind of wonder if you can do this thing, and it'll just figure it out for you. And maybe the answer's no, but often it's yes, and then it does.
Yes. And in particular, you don't have to raise tons of money from investors and recruit a team and whatever, which you would have had to do to build a software application for a early computer, right?
So it's nearly free.
Yes. So it's nearly free and very general purpose from day one. Okay, so that's point one. Second thing that occurs to me is, so we talked just now about how when AT&T was automating their telephone exchanges, they started with the big ones, and over time only later do they get to the smaller ones, because you pay this upfront cost of a fixed cost of switching over, which means you really have to have big scale to be able to bother to use it, right? To make the switch. And so in general, automation requires scale. I think Generally for LLMs, you can get real value from them with basically no scale at all. So you can be a one-person whatever, and you can start using it in your day-to-day life. You can adopt it yourself as a consumer almost, as a sort of producer-consumer, and use it, and it's useful straight away.
And that's basically because the fixed cost of it is already super low. It's like you can get a subscription to GPT-4 to use it as much as you want, basically,
yes.
at very little cost. So you can do that, have all the benefit, or like have most of the benefits, and you're not like building, I don't know, server farms to like run the thing. That's like basically done, and the only cost you is tiny.
Exactly. And indeed, one way of thinking about this is that kind of there's a massive fixed cost of training it for everything. But like OpenAI already paid that. They paid it once for everyone. And it cost them hundreds of millions of dollars, whatever, right? But like it's paid now, and it's therefore the marginal cost for us all is tiny, which means that you can then adopt it throughout the economy. And then because of the first point of it being general purpose means that, loads of different people can adopt it basically instantly. And it's also just like much cheaper for, any company that's putting it into a production process system. I think, that it's not trivial, but it'll be generally much easier than doing a big software upgrade or whatever. So this next point is around, normally, most kinds of automation, new technologies require huge complementary changes to be useful. So there's a classic example of this, which is back to electricity. There's a great article called The Dynamo and the Computer by Paul David, which sort of makes this point, which is in order for electricity to sort of have its impact on the economy, like a ton of stuff had to happen. So like, obviously you had to like actually lay out a power grid. So you everyone had to either get their own local generator or ideally connect to a, much bigger scale.
So that's that big fixed cost thing.
That's a huge infrastructure fixed cost. Okay. But then beyond that, so think about all these factories making, at this point, I don't know, bicycles. Who knows what they're making, right? And they are all set up to be running on steam power, and that generally means that you stack the factory vertically for reasons that are not worth going into, and often they're going to be these things are in city centres, and there's all kinds of things to do with the fact that they're running on steam that affect their design. And once electricity comes along, and the dynamo and things which convert electricity into motive power, it means a few things. One, it means that your location is often much easier. You don't have to be in the middle of a city or near a river or various things that affected steam power. Also, it means that you do not have to have this sort of funny vertical design. And in fact,
you're better off. Do you mean that
literally? Literally, like, think about vertical farms, right? They're like very sort of thin and tall. Like that's how factories were designed. In the UK, and you go to Yorkshire, you see all these like very tall factory buildings.
Okay.
For this reason. And so with the electric motor, suddenly you can bring the energy to the machine and put the machine wherever you want. And when you can do that, it turns out that the best design is actually a entirely large, sort of flat, horizontal. It's like, because moving stuff up and down this vertical thing is like, it's loads of energy, is like really annoying. And so you want a much bigger factory that's on a single floor, and you're going to have a completely different layout for your machines. Your machines all need upgrading, obviously, as well, and in various ways. And this all means that it just takes a ton of time to make all these changes. Because in particular, when this new electricity thing comes along, you've got all these factories running on steam. And they still work fine. Right? They work. They're profitable. They're making the products and you're selling them, and it's all fine. And so if you're like, okay, I just made this fancy factory for steam that's based around steam power. You're telling me that I can build a new factory somewhere completely different. There's going to be like a huge capital outlay, expense of building a brand new factory in a different place, a different design, different machines. Like, sure, maybe I'll do that in 20 years' time, but I just built my own steam factory and it's working. So I will, get the investment payoff from doing that, and then maybe if you're lucky,
get the value I can from it.
Exactly. Then I'll start and turn my attention to this other thing. And so this is another reason you just wait. There's the time for the power to be spread around the country, insofar as you waiting for the power grid. There's a time to wait for your existing investments to pay off from the steam, which might be 20 years. Who knows, right? Then you have to wait for generally everyone else to try it first, so you make sure that it works before you take the risk of trying it.
And this doesn't seem like the case for AI. It doesn't seem like if GPT-5 comes out, there's no reason for me to keep using GPT-4. I'll just switch. There's no cost.
Yes. So within, I guess, sort of vintages of GPT or AI, there are definitely, I think, relatively limited costs of switching. I think they're not zero. I think that sort of your prompts will be carefully designed and tuned for whatever, right? So you'll have to, if you've got a whole system running on these sorts of prompts, you can't just like upgrade everything in one go. You have to test each thing and make sure it's still working in the way everything thinks and whatever. But I think there's a more interesting type of sort of upgrade, which is from not using any GPT to using it for the first time, right? Sort of, so you're going from, you don't have LLMs in your company or startup or whatever it is, to suddenly you're now using them a lot. And so we've talked about how for the other technologies, it's a big deal to switch from steam to electricity. And a quick story. So I once talked to someone who was some kind of, fancy senior person at like Deloitte or KPMG or one of those kinds of big four accounting companies. And he was talking about, one thing these companies do, or some of them sort of, I guess the more sort of IT consulting-y ones, is they help companies with big IT transformations. So like moving to the cloud or, upgrading your software, whatever it is.
Yep.
And many companies, particularly the big enterprises of this world, will run, they'll be really deeply sort of embed with software that goes under the name ERP, so enterprise resource planning. So Oracle is one of the big ones. Sort of all your finances and the whole company runs on this single big bit of software. And so the story this person told me was that this company itself had recently tried to, I'm going to make up the details, but they tried to upgrade from Oracle version 13.1 to Oracle version 13.3.
Okay.
And the thing I remember he said is that this upgrade, which failed or was botched, that attempted upgrade cost every partner in the firm a Ferrari. Which sort of puts it into sort of stark terms, right? Which is to say, it's really, really expensive to change software in companies, in enterprises. Partly because people designing the software, they deliberately try and build them so it's hard to switch. Like they're called sort of switching costs is the word people use in sort of, software, the SaaS industry, whatever it is. You sort of make it hard for people to switch away from your bit of software by sort of embedding yourself.
And that's from like one company's software to another.
Yeah. And my favorite example is I think there was an Australian bank so these banks often, they're very old companies and they adopted IT fairly early. So they have these like mainframe computers that sort of everything still runs on, right, from the 70s or who knows when. And these mainframes are written, often they're involving like programming languages for sort of bank business logic that were big in the 70s, but like no one knows anymore. So I think COBOL is an example of one of these languages that there's like millions of lines of business critical code written for many enterprises in COBOL, and like no one knows COBOL anymore. People, you can learn it, but like it's
never heard of
it. You can't easily hire a COBOL engineer. And so switching from the big bank mainframe to a sort of whizzy fancy new thing into the cloud, whatever, is a massive nightmare. So this Australian bank, I think the story I read was like it cost them like more than $1 billion for the IT upgrade, right?
Oh my God.
Which sounds insane, but like that is how much these things cost. That is why it takes, 50 years for IT to be adopted, because that's the kind of costs that are involved. You have to like retrain your entire workforce. You have to rewrite millions of lines of legacy code. If it goes wrong, like that is a complete catastrophe for your company, because your customers suddenly, the money appears to disappear from their bank account, right? Or they can't access the money, whatever it is. Like the stakes are really high. So that just means the cost goes up and up and up and up and making these kinds of changes. So what's different now? Well, LLMs, they speak any coding language, right? So just imagine you're now this Australian bank and you were being like, oh my God, I gotta pay like, $1 million a day to hire these fancy COBOL coders to translate all of my old business logic from COBOL to whatever new language it is. That cost has now just disappeared. Can be done out of the box by GPT-4. Because GPT-4 speaks these languages, it can just like get rid of all this friction. Like, it's amazing. I don't think people have sort of, had enough experience with this yet to actually start experiencing that at a sort of meaningful scale. But I think it just represents a huge opportunity to any startup building, sort of SaaS software, which before would have been impossible to persuade anyone to switch to you because it would have been too expensive. Or, man, it's going to be way cheaper now. And also in terms of training, it's also now much easier and faster for you to sort of use LLMs to help you build for example, interfaces that look just like the old one, even though your new thing is under the hood, right? So it's very cheap to build all kinds of, new bits and bobs and customizations and whatever, because LLMs make that basically free. And it wouldn't have been possible before because it would be too expensive because the programmer's time being too expensive. Now you can just do it and everyone can make their own interface, whatever. It becomes so much easier. So that is, I think, a huge, huge reason why LLMs will be adopted faster themselves and also cause faster adoption of like everything else.
Of other technologies. Right. Cool. Okay. So part of it is just like they speak like the languages we speak. And so learning them is like learning how to incorporate Claude or whatever into your workflow is much easier than learning Excel for the first time or something. But also it can help you engage with Excel better. So you don't have to learn Excel. I mean, probably, Excel is maybe the wrong example, but...
Well, no, seriously. So take Excel, right? Suppose some fancy new version of Excel comes along, right? If you're a big company, you're investment bank, you have always analysts who work 12-hour days with their fancy Excel spreadsheets, and they've got all these custom VBA macros they've all written to do certain calculations, whatever, right? Suddenly, all those custom VBA macros can be converted into whatever the new thing is, like instantly, as opposed to taking months and months and years and years.
Yeah. Okay.
So Excel's a very good example, in fact. Yeah.
Great. Okay. So there's two kinds of effects. And it sounds like both of those create, again, disanalogies between AI and previous technologies.
Exactly.
Yeah. Are there other disanalogies?
There's one quick point I want to mention. The analogy is that you often start by, automating very tiny things and, a very specific process that has some input and some output, and you're like, right, I can keep everything else the same and then just change that process, right? But the real benefits of almost any new technology generally come when you take a step back. You're like, you know what? Now this thing exists, I can rearrange everything. So back to the example of steam to electricity, once you completely rearrange the factory floor, actually that means that not only do you sort of not have to sort of, carry things upstairs the whole time and downstairs and all that time, but you can do loads more stuff. You can suddenly have assembly lines, right? They become possible. You can have assembly lines. And that's a huge productivity improvement, right? An example that Eric Brynjolfsson, who's an economist, who thinks a lot about these things, likes to use is, what do you think about a watch, right? Think about an analog watch versus a digital one. When we, quote, automate the analog watch, what we do not do is take each individual cog and say, let's take this cog and replace it with a sort of digital cog.
Right.
No, you completely reimagine the whole thing from the ground up, right? And it just looks completely different.
Right.
And so the question is, what does a business economic activity that has been reimagined from the ground up to take account of what LLMs can do, what does that look like? One big way that I feel LLMs are sort of different than before is it's possible to take humans out of the loop in very interesting ways, or at least to have humans not be a certain kind of informational bottleneck. So if you think about the CEO of a company, right now the CEO of a company, the way they get information is they either go onto the factory floor or the retail floor, or sit in on a customer, whatever the company does, right? They can get some sort of anecdata by just sort of randomly sampling a bit of real thing. And then that's sort of bucket one. Bucket two is they get these sort of reports written for them by, endless hierarchies from the bottom level to the top level. And
sure.
Every time the report goes up from the sort of sub manager to the sub manager, it's sort of information is lost and things are summarized and they're made to look better than they really are and things are hidden and you can't spot patterns and whatever it is, right? So now, once sort of businesses are running entirely, as it were, with LLMs sort of involved and sort of all information is in the cloud and so on, suddenly, just imagine, what if the CEO had the personal experience, all the information from every customer service agent, every salesperson, every machine on the factory floor, right? Suddenly, all kinds of, innovations and sort of more sophisticated strategic thinking, and, better operational management, all these things become possible. When I was in government, I really, really felt this because, you were sitting, I say at the top, it sounds, fancy, but it was the bottom, really. So you're sitting at the top and in number 10 or wherever. Or here's a question, right? How much AI research is the UK government currently funding? The UK government does not know the answer to this question. No one's bothered to go and label every single grant application with the word AI or not. right? And these application systems are all in completely different systems and different research councils and bits of government funding agencies and whatever it is. And so, I asked this question and it took 3 months and we finally got a sort of an answer that was, a good attempt given the data available, but still was nowhere near a sort of, sophisticated answer to the question that you'd want to have to make a good decision on various things, right? That's even in a world where sort of everything is already sort of digitized and in databases. Is the human labor required to go and sort of read every grant and label it as AI or not, whatever, right?
Yep.
Whereas now an LLM can just a CEO or senior person who cares about allocation of resources could ask that question and instantly the equivalent of hundreds of thousands of human hours of labor of carefully going and reading every possible application for funding, whatever, can just happen. And that really changes the nature of decision making.
Right. Decision making. Yeah.
And it also really changes the power of people at different, the really interesting sort of organizational sociology stuff here, because, people in the middle managers have lots of power because they can hide things from the higher ups, right? And they can, present things as they want them to be seen. And if the sort of the more senior people can suddenly, they can ask an LLM a question and it's it will read everything from every customer service chat or whatever it is. That's not going to lie. Assuming it's set up right. Another question, but in theory, that's not going to lie. And suddenly you can do all kinds of things you couldn't do before. So I think that's the way in which, again, this is going to be really different from other technologies. Again, there's analogies and disanalogies. IT certainly made centralization much easier because suddenly headquarters can sort of keep in touch with all these distant places much more easily than before. Or sort of information and communications technology. I think this is kind of this is the whole nother level of that, which is going to be absolutely fascinating to see what happens there.
Great. Yeah. Okay. So that seems like a lot of differences, which, I'm just really having this feeling of does it even make sense to try to draw analogies from previous technologies? But I guess it sounds like you think that at least some things are similar and that maybe, I don't know, you'll tell me how much those things matter. What will make AI similar to other technologies that have been kind of, general purpose, big game changers?
Yeah. So I think there's two buckets. There's a sort of humans are humans bucket, and then there's the government bucket.
Okay.
So let's start with the government bucket. The government bucket is basically regulation. So I put in as a broader bucket, sort of just call it collective action. So government is one kind of, societal-wise collective action, but there are other things like unions and professional bodies and all this kind of stuff, right?
Sure.
So here's a question. Do you think that in 10 years' time, so it's a long time, 10 years' time, you'll be able to just talk to a language model and it will prescribe you a, prescription-only medication which you can then go and collect from a pharmacy? Do you think that'll be legal? Because, by the way, it's possible today, right? Sort of it's good enough. Basically, we're there, right? You can do that already today. It's going to be good enough. Would it be legal? Yeah,
I guess as soon as I start thinking about it, I'm there are a whole bunch of interest groups that are going to want that not to happen. There are some interest groups that are going to feel worried that it's going to make mistakes. There are interest groups that are going to, just want to be protecting the people in the jobs that are doing that now. And so it seems at least plausible to me that people somewhere will decide that we shouldn't make it legal. Though, I don't know, in 10 years, it also wouldn't surprise me, to be honest.
Right. So you're absolutely right in the sense that there are these very powerful interest groups. And so, some of the areas that will be most affected by AI that we all agree, I think, seem very likely to be affected are things like what the doctors do and what the lawyers do. Doctors and lawyers separately have the most powerful lobby groups you can possibly imagine, right? So the American Medical Association, the British Medical Association, and then for lawyers, it's the bar council, the, various solicitors thing, right? So here's one thing that happens. They do all of the kind of professional standards for that profession. Of course. And they decide who gets to be a doctor. And they decide how many doctors get to be accredited as doctors every year, or lawyers, whatever, right? And so if you just open a newspaper, basically any day of the week, and you will see how powerful doctors are. So another example is you might think, sure, it's obvious, right? That sort of video consultations are just more efficient and better for patients for most things most of the time. And we should just have them as an option. It literally took COVID to go from doctors saying it's completely unsafe to allow people to have these remote consultations. It's like, it's not okay. We shouldn't allow it. It's banned, right? To, oh shit, like it's any option. I guess we have to do it. And then now it's like, okay, everyone now does these things. It's much more common, right? But they were able to block it, essentially. Like the government couldn't make them offer e-consultations. And the government tried to and failed for many years, I believe. I'm not an expert on that exactly. And so, similarly, lawyers lawyers are very good at manipulating the law, as you might imagine. That's me. That's unfair.
Yeah.
They don't make them, obviously, in terms of legislation, but still they're very, very influential. And so they are the sort of gatekeepers to this kind of work, and they make it literally illegal for you might think, why didn't a startup come along and just do it online for free? And it's like, well, no, it turns out you can't do that because it's literally illegal, and they're the ones that make it illegal in practice. And so, regulation has always been something that is kind of regulation by the government / collective interest groups. So unions, whether they're sort of, blue collar unions or whether they're, professional white collar workers, which sound like they're not unions, but they really are unions. Right. They don't have the word union in the title, but they definitely are unions. They're very, very, very powerful. And so these really, really slow down all kinds of applications, possibly for good reasons, a lot of the time, right? Sort of open question for any given question, whether we should or shouldn't slow down the application, given the harms involved. But they are always going to argue for, no, you need the human completely in the loop, and we shouldn't change anything, and we should keep our salaries the same, and so on and so forth, right?
Right.
So you might think that doctors are going to be hugely changed by AI, and maybe it'll sort of bifurcate into a job that requires much less medical knowledge and much more empathy, sort of closer to a nurse, and sort of the doctor kind of uses GPT and interacts with it a lot more, right, on the one side, and then sort of a smaller number of very, very, very specialized people who somehow are even better than GPT-4 at medicine, which, if that's possible, I'm not sure, right? And so, is that going to happen? And if so, that feels like it would be a good reason not to go and assume we're going to, if you wanted to sort of have a nice, steady, well-paid life, being a doctor might suddenly seem like, well, you're kind of choosing to be a nurse now than a doctor, and there's a different kinds of career paths for certain people, right?
Right. And that's the dynamic we talked about earlier, where people that don't have the skills yet might have, fewer incentives to be like, I definitely want to be a doctor, and then I definitely want to lobby hard for AI systems not to replace doctors. They're just going to be like, seems possible that AI might at some point replace a lot of the tasks that doctors do. So I'm going to go into this adjacent profession that does seem like there's going to be loads of demand for it.
Exactly. And so what? So one, that might happen. And in addition, it might also be the case that the doctors' union is successful at preventing any change. And so this change does actually happen. And so you have fewer doctors going into the profession and no AI-enabled, diagnosis and primary healthcare, whatever. And so everything actually gets sort of slowed down and gets worse because of the interaction of the automation and the regulation. Right. So I have no idea what's going to happen in any particular case, right? But I think we can be extremely sure that there's a ton of interest groups that are going to be pretty successful for a pretty long time in stopping things changing faster than it's in their interest for them to change.
Yeah.
So point here is AI is not immune from this. In fact, if anything, it's so salient, it's going to be extra subject to this. And as we're sort of hearing, there's ever more talk of regulation of these models, right?
Yeah. And I guess there has been things in, Italy is no, GPT-4 is
And they banned it and then they've unbanned it, but...
Oh, they've unbanned it now. Okay. But that kind of thing, yes. I guess that's just an example of a thing where that kind of thing will happen.
Exactly. I think it's distinguished between what might slow down the progress of the frontier models, which is what a lot of the sort of the chatter is about sort of right now. I'm mostly talking right now about forget whatever the frontier thing can do. Is that going to actually be used in the economy? And that is a very different question because the doctors' union is going to get in the way of that.
Yeah.
So that's sort of that huge bucket that I think is and we could talk for a long time about that. And it's it's really, really, really important. Nothing has changed there. If anything, it's there sort of people are stronger before, right? So, that's that. Okay. Then other bucket of kind of humans are humans in terms of the way they make decisions. So I talked about how LLMs can sort of make it easier to retrain, but you still have to want to retrain, right? Or do things differently in some way. And so think about teaching as an example, right? Sort of LLMs could completely change the way classrooms are run. And the teacher will spend much less time marking and maybe lecturing and more time giving one-to-one support, whatever it is, right? Now, maybe teachers want to do that. Maybe they don't. I imagine most of them would want to do that, actually. But one thing I'm quite sure in saying is that there is no way the government will be able to force teachers to start adopting this software and using it in certain ways. the teacher is like master of their classroom, right? And there's been many examples of, governments wanting to make teachers do things differently, and generally it's very, very hard. I mean, occasionally, I don't know, like phonics in the UK, sort of things sort of can change in certain places, but like in general, teachers' unions have a lot of power, and the government cannot control what happens in classrooms. And so that again applies in lots of different places. So the stronger the union, the more it applies. But in general, humans don't like change for the most part. They like things the way they are.
Right.
And at least, if you're doing a job.
And like learning new things is like kind of scary.
Yeah.
It sounds like you're actually using Claude quite a bit. I'm using it some, but like I could totally be using it more, except it's like kind of aversive. I'm like not exactly sure how to do it. And so there are some things I'm just like not bothering to learn, like how to do like a particularly good prompt to like figure out what my interview questions should be. And like, I don't know, I'm pretty curious and like open to change. And loads of people I think are even less open to change than I am. So yeah, that does make sense that when you look at humans actually on an individual level, they are less excited to learn new things, and especially have those changes like imposed on them, then we can just like imagine.
And it's often more than just a sort of a change to what you're doing that has bigger sort of second order consequences. So for example, suppose you're a teacher and you've sort of spent years making these amazing, ways of teaching things and mark schemes, and like you always do your marking from 6 to 7 p.m. and then after
Right.
dinner, whatever. And suddenly like your entire life has to be completely reorganized because, the LLM is doing the marking, but it doesn't always get it right, and whatever it is, right? It's sort of, and you've all the stuff that you've invested of your own, your own human capital, your own time, your own loving, tender care of like creating these certain ways of doing things. You're being told, what? Suddenly that's like not worth it, and you should stop using them and use something else, which appears to be worse to you on the face of it. Like, no way, right? And like that happens everywhere for most people all the time with new things. And this is certainly a new thing, right? So that's another sort of category. Another subcategory of the sort of humans being humans is, I guess this is sort of one of the more obvious ones, is we are generally liable for things. And, if you make mistakes, it's sort of generally, it's not an acceptable excuse to say, oh, I'm sorry that person died, the AI did it, right? Or I'm sorry that the money left your bank account that wasn't supposed to, it was the AI's problem. Like, that's not an excuse. You have to put it right. And you're liable, right? And most companies, most of us spend most of our time interacting with very big companies. Like most people work for a big company. And big companies have brands to protect, and they don't want to take risks. And so they're going to be really slow and conservative about introducing LLMs, which could be amazing, but like there maybe is like a 0.1% of chance of an error. But like if you're really big, that 0.1% is going to happen at some point, and it's going to be a big news story. And so you're not going to adopt it until you're sort of 99.9999% sure that it's going to be always working, right? And not causing a PR disaster.
Yeah. Actually, that reminds me, I've kind of tried to use Claude to prep for podcasts, but Claude just lies sometimes. And I'm like, if I don't know for sure which of the things are true and not true, I'll like lie on the podcast, and that seems really bad. And I'm kind of just like waiting to like somehow hear that like goes down. I'm not like racing to figure out how to use it in a way that doesn't involve not truth telling. I'm just gonna, at some point, I'll like get the sense that like the risk is low enough, and who knows how long that'll take.
Exactly. And different people will have different sort of thresholds, right? So
right, for risk, yeah.
If you're like a creative writer, like who cares whether it's making something up, because you're not trying to be fact-based anyway. I guess, that's not insulting to creative writers. Like that's not the point. You're not supposed to sort of track events in the world, whatever. But if you're a lawyer, like if you, quote a case doesn't exist, as in that case earlier this year.
Has happened.
Right, like that's really, 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 really bad. And so the threshold for, you and me using it might be, 90% accuracy. If you're a lawyer, it has to be like 99.99999%. And it'll vary by different tasks, right? But then another point based on what you just said, which is sort of, I'm going to wait for it to get better. That is a huge, huge deal in terms of, if you're in a world where it's very obvious to you that this technology is getting better all the time, and you know that you will incur a fixed cost to adopt it, and when you have adopted it, you won't be able to re-adopt it or upgrade it. It'll cost you more to upgrade it again later. When do you make the decision to sort of adopt it in the first place, right? So there's actually a whole bunch of work in operations research, which is a sort of a whole discipline, right, of like how do you run certain bits of companies' operations effectively, efficiently. There's a whole bit of sort of that which looks at optimal technology adoption. from this perspective.
I guess in Australia, these banks that got whatever computer system you were talking about to do their banking calculations kind of got it wrong. They invested in this thing that meant for decades after they couldn't get new software because it didn't use the right language. And it did strike me that there's a real optimization that they have to do.
Yeah.
That's you want to be on technology quickly because it's going to make you more efficient. But too quickly and you'll get stuck in some suboptimal early stage.
Oh man, you're stuck. Yeah. Or maybe they were right to adopt it in the 60s or 70s, whenever they did, but but they then knew that okay, we're not going to be able to upgrade it for literally 50 years and it will cost $1 billion. So when do we make that $1 billion investment? In 1990 and 2000?
Yeah, it's just a hard decision.
Yeah. So that is a decision that faces businesses, and it's a harder decision for bigger businesses that are more complex, and most of the economy is bigger businesses that are more complex. And so you will ultimately just wait. Many people ultimately wait a long time before making really big, important decisions about adopting this, because they're seeing how fast it's moving, and it's why not wait a bit, right? So, and then a major point of that is you'll also just whilst waiting, you get to watch other people, and you can learn from other people's mistakes rather than making the mistake yourself, and let them incur the costs. So let the early adopters make the mistakes, right? And then we sit back, and then the late majority, whatever, they get to adopt it at a time when it's much more much less of a risk and more of a guaranteed thing.
Yeah, a bunch of lawyers just learned that they can't use GPT-4 to write whatever legal documents without having these hallucinations. And so they're going to wait until it doesn't do that.
Exactly.
Yeah. Is there anything else we should be thinking about with regard to how the AI version of this technology rollout is going to look relative to other technologies?
So I think one piece we haven't touched on yet at all is what economists call market structure. Or industrial organization. So namely, is this technology something that is kind of controlled by a single monopoly supplier, or is it completely distributed, anyone can use it for free, whatever? Those are really, really important questions for speed of adoption, because basically the short answer is, if you are a monopoly supplier, i.e. you're the only company that can possibly provide this product, then you are generally going to set prices higher than you would if you were competing with others providing the same thing. And if you set them higher, then that's going to mean that fewer people can benefit from using it. And it also means that you get more of the profits, and people are paying you more than otherwise they would. And so you're concentrating wealth in these few companies rather than it being more equally and broadly distributed around the world. And so there's one kind of meta point I want to make first, which is I think of GPT-4 tokens or whatever as kind of bandwidth in the telecoms system, in telephone lines, fiber or whatever. So if you talk to people in telecoms who've been around for a long time, and maybe they run big telecoms companies, whatever, they'll tell you the iron law is that people never stop wanting more bandwidth. And this is just an analogy, right? So the analogy is, in telecoms, you might think at some point there's enough telephone wire laid, right? And it turns out no, 3G, then 4G, then 5G, and all the people want more and more and more and more. I think access to these language models will be very similar. So right now you might think GPT-4, it's I don't know what the cost is per token. It's it's less than a cent, right? But it's you might think, gosh, that's basically free. No, it's not. That's actually really expensive. And the applications you can imagine for these things, many of them will depend on having ever more unlimited access to tokens. And so think about the example I gave you earlier. You're the government. You want to know how much AI research has the government spent money on so far. That's one question that involves reading, hundreds of thousands or millions of documents and pages and whatever, right? And right now that would cost you quite a lot of money. That's just one query, right? And so right now today I spend probably, $5 a day, it feels like, just, on my queries to Claude and GPT-4. And sure. I can afford that, but if I'm a student using it to tutor me, and I'm, $5 a day is actually a lot of money. It's a lot, it's more than many people, way more than many people have available for anything, right? It's on a global level. So the cheaper this stuff can be, it'll have a huge impact on, who gets to benefit from it, and how do they get to benefit from it, right? And so right now there's basically like OpenAI and Claude, and then like a few others. Maybe Google's going to have something that's like as good as GPT-4 at some point. One lesson for economics is that 3 providers is basically not that much better than a pure monopoly. It's a bit better, but like you have to get to more like 10 providers before you have something that looks like the sort of economist version of, perfect competition. I.e. when you're sort of offering it at cost, you're not sort of putting a big margin for your profit on top, right?
Because you can. Yeah.
Because you can get away with it.
Yeah.
And also when you only have 3 providers, it already feels to me like there is some differentiation happening, and that like Claude is just better at writing tasks in general, and GPT-4 is better at coding tasks in general right now. That might change over time, but like right now, that's my experience of it. And so if I'm a coder, I don't really have much choice. I have to use GPT-4.
Right. It's even more of a monopoly.
Right. And so sort of they are a monopolist now in that little segment. And that's a really, really, really big deal. So if, regulation gets brought in that doesn't just stop, incredibly potentially dangerous, much larger models from being built, but mostly functions to stop new players doing anything at existing scales, then that is going to have huge impacts on, what the benefits to the world are of these technologies. Because the benefits really come when they are close to being free, right? Not when, you're making a little bit of margin.
The richest people can afford them.
Exactly. And so I think we should really get in the habit of thinking of this stuff as if it's, it's like bandwidth on your phone, and we should be wanting ever more of it, ever more cheaply. And we should do things to make sure that it is cheap. Another reason why AI is like telecoms, because telecoms, to offer phone service, you have to like have all these cell phone towers, right? Or lay this cable, and like it's really expensive. And so not many companies can afford to do that. And so you end up in a world where naturally you just have a very small number of providers. Historically, what's happened is the government's ended up regulating those providers and capping their profits. Thames Water is the only water supplier in London, right? You have no choice but to use Thames Water, I believe. They have a complete monopoly. However, the government also...
They can't charge whatever they want. They have to charge some amount that's...
No, the government says, sorry, you can charge exactly this much and you can make this much profit. And sort of bad luck, as it were.
And they'll do it because it's worth it, but the prices won't be exorbitant because that's just not allowed. The government thinks that would be unfair, and rightly so.
Exactly. And so these are sort of generally, they're like listed companies. You and I can invest in them if you want to. And they're on trading on stock markets. They're completely sort of independent corporations. They're not part of the government. They're not nationalized at all. They're independent. But the government says they have price controls. They say how much they can charge, right? And so one sort of thing I would expect over the next few decades, potentially, depending on what happens sort of with the market, sort of if we end up having regulation that kind of, for safety reasons, stops all these smaller players from coming along, then the government will end up saying, you know what, OpenAI, you're basically like AT&T, and we're going to cap the amount of profit you can make and the number of, what you can charge per token or whatever it is. And these become very dull and boring companies, kind of like a water utility company, right? Or become sort of the AT&T, and maybe there's a Bell Labs attached to it, but it's sort of the main thing is the AT&T thing. And I think there's like a bunch of really interesting sort of political economy things there around, speed of adoption will be very much affected by what the price of this stuff is. The cheaper it is, the faster it'll be adopted. The more expensive it is, the slower it'll be adopted. Even what we already have, right? Which could sustain decades of really exciting economic growth and progress. So that just feels to me like a really important fact and big deal.
Right. Yeah, it seems like that could have a couple of effects. One is like if it caps the price for consumers, it could be much more widely adopted, and the things we have now will have like wider benefits and across like a wider range of people and industries. But it also seems like it might slow down further progress if OpenAI, for example, like less profitable for them to build or to like push the cutting edge. Is that something you'd expect to see in that world where the government did cap?
Yeah, well, I mean, look, like water companies are not famously innovative.
Exactly, right.
Although, there's an interesting thing with Bell Labs. So I'm not an expert on the history of AT&T and R&D and so on, but like one thing I believe is the case from having read a bit about it is that they kind of staved off regulation for much longer than you might expect by investing in things like Bell Labs and saying to the government, look, we're doing all this really important R&D stuff with our profits. This is good. This should exist. Well, you could have the other way around when the government say, the government, here's a clever thing the government might be able to do. Right? The government could say, we're going to cap the cost at this amount. The cap is going to go down by 50% every year. If you can figure out a way of doing R&D to mean that your costs are way less than 50%, then you can keep all the profits you make. So a smart government could nevertheless, incentivize the sort of things it wanted to incentivize if it was thoughtful and clever about it. There's lots of other ways of doing this, right? But I think there's more to it than just, it'll reduce innovation. There's all kinds of ways you can set things up so that it might actually encourage innovation of the kind you want to see as opposed to the kind you want to avoid.
Yeah. Could AI progress just outpace the government's ability to create these regulations? It seems like I think of regulation, in general, as like government policies as like being just slow moving. And like maybe they move a bit faster when like there are extreme things happening in the world. But I guess COVID was extreme and some governments were able to move somewhat more quickly than others. But even so, it seems like all things considered, it would have been better if they'd moved faster, and they still found that hard. And AI seems like it moves incredibly quickly. If we're going to get improvements to GPT-4 that basically like double from the ones that we got last year in the next year, will there already just be really extreme impacts? Not just impacts, but I guess like adoption that means that some of these regulatory effects just like don't keep up. And so don't slow things down. I guess the way you might expect they would, or they have in other cases.
Yeah. I think that, so the things we were talking about before in terms of all the reasons that, interest groups and lobby groups can slow things down, like, as I said, I think those very much apply here. And so even though the technology is moving really quickly.
Okay. And they will keep up.
They will keep up in terms of by stopping it being used, right? Whoever fast is moving, you can always pass an order to say no, right? So, the thing that I'd be more worried about is the sharp end of capabilities and the things that, you've had many guests on this podcast talk about, and as well as, misuse and those kinds of things. That's where I'd be more concerned about regulation keeping pace, because there it's not like you have to persuade lots of people in the real economy to adopt your thing and change their systems. All you need is like one bad person to have a very clever thing and to do bad stuff with it, right? It's those kinds of things that you have to worry more about regulation moving fast enough. But even there, I think, I'm not an expert on the history of like nuclear regulation, but I believe something like the following is true. Like at some point, someone convinced the US government, the US president, that like nuclear was like a really big deal, and it was possibly, very, very dangerous. And with a single stroke of the pen, I don't know whether it was a presidential executive order or congressional legislation, whatever, but like almost overnight, all research on nuclear anything was classified. Right, so you're a researcher, you're just like doing your PhD, whatever, or sitting at home doing some physics of whatever. Suddenly, from tomorrow, you doing any more work on that is illegal. The government can just do that, right? The US government can do that. And you can imagine that like if people do enough to convince governments that this stuff is really, really scary in terms of the sort of the existential risk level of this, the government can be like, yep, okay, you convinced me. As of now, we are classifying all research on AI. Right? That could just happen tomorrow, and then all these companies would just shut down overnight, and that would be the law, and they couldn't do anything about it. End of story. Right? That's completely a possible in terms of the powers government have scenario.
Okay, so it's not that fast government action is impossible. It's that it doesn't happen that often. Sometimes it does happen. I don't know, suboptimally. It's too slow.
Always it happens suboptimally, right? Like it's either too slow
right.
or it's too fast and it's too blunt.
Or too fast.
So you might think the nuclear, I'm not an expert. I imagine there's kind of stuff that was classified under the nuclear stuff that was completely reasonable to not be classified, and people should still argue, but they couldn't, right? And maybe we'd have much better nuclear energy today if that hadn't happened. Right. So there's all kinds of, ways in which any regulation is going to be very much not first best, second best, or, at best, third best. And I think, we're in a really scary place right now because, regulation, if it happens, could do a lot of good. It could do a lot of harm as well. And so we're going to have to tread, very, very, very carefully.
Yeah. Okay. But the key thing I'm taking away from this is if I had some intuition that fast government action is like unlikely because you just don't see it that often, it actually is totally possible, and we just have to do a good enough job convincing government that, especially the safety stuff, is worth taking seriously. And then, were we to do that, things could change very quickly.
The thing I would take an issue with is sort of do enough good job of convincing. What you're kind of doing is you're sort of, you're waving a red rag in front of a bull, and you want the bull to jump in that direction, and it might do, but it might jump in the complete opposite direction. And you don't know in advance which way it's going to jump. And so, anything where you're trying to get the government to do a really, really, really big thing, like by default, it will do nothing. But there is a small chance it will do a really big thing, and there's a big chance if it does that it will be really bad. But it could also be really good. So it's just like, or the only thing I'd say is like it's very high stakes stuff, and it needs to be thought through very, very carefully. Yep,
makes sense. Sounds right. Yeah, so I guess we've gone through lots of reasons that I guess the kind of deployment of these AI systems as they get more and more capable, it might be similar to other technologies historically, which might mean something like it takes decades, 90 years, sounding like it's a surprisingly common default. But there are some disanalogies that make it sound like it might be much quicker. Those seem pretty important to me. So it seems like putting a fair bit of weight on that path to like put some like parameter or like, upper and lower bounds on what we're talking about here. So I guess in the pessimistic, well, I say pessimistic in quotes, the case where it's like deployed more slowly for lots of these reasons, like government intervention and I guess like humans being humans and other things. What do people think the impacts on the labor market in the next few years? So not in decades when maybe AI is like much, much more capable than it is today, but in the next 2 to 5 to 10 years, what do people think might happen on the like low end of impact and change?
So I think sort of some of the most pessimistic people are professional academic economists, and because they've seen this all before, they think at least, and all the things I was just telling you about, sort of they all see the analogies, and maybe sort of haven't spent that much time thinking about the disanalogies, and so there's a great thing called the IGM Economics Experts Panel, which is a bunch of like seriously like the very, very top of the field, absolutely brilliant people, sort of professors of economics at like all the best ones, and they ask them these questions it's every week or whatever it is, and they all give a sort of their answer in terms of what they think will happen and like how confident they are. And they recently asked, do you think all this fancy AI stuff is going to have a bigger, will it have like a really big impact on GDP in like the near future? And like they basically all were like, no, like it's not gonna, like maybe it will be as big as the internet if you're lucky, but like that didn't show up in GDP statistics much for a very long time.
Interesting.
And so one point is like GDP growth has been slowing since the 1950s. That period post the 50s had involved amazing innovations of all the computer and who knows what, right? And that's like 60-year period involved that amazing stuff. Like you're telling me that AI is going to be sort of better than all those things, and so I just don't think we'll see anything showing up in the GDP statistics. Like we're not going to be in a world where suddenly we've got 5% growth in the US, which would be completely economists would all fall off their chairs if that happened next year,
right?
For sure.
So out of distribution.
Yeah. So that's kind of what people say who are more pessimistic. Yeah.
Got it. And what's the story they're telling? I guess it sounds like kind of just an outside view kind of prediction. It's like there are loads of like impressive new technologies that have been developed in the last few decades, and they don't cause perceptible changes to the GDP. This is another one of those, and not doing much like updating on the like specific facts about AI. Is the story that they have in mind like yes, there will be some adoption, but it's not going to like double or triple anyone's productivity. It's not going to like automate away so many jobs that like, I don't know, there's like 150% increase in the like labor available to do more work. Does it assume that like the predictions about what AI could plausibly do in terms of boosting these kinds of labor inputs. They just think they're overblown?
I think a sort of charitable version is think back to 1960 and computers, the first computers are being invented. And the inventors of the computers say, look, this can do anything, right? We've got all these humans doing loads of jobs involving, tabulating data and, storing, retrieving, manipulating numbers and addresses and databases and all those kind of stuff. And look, this computer can do all of that. Just today, right? And initially you had the US Secretary of Labor, Willard Wirtz, in 1963, giving a big speech saying, we're going to have, we are quickly about to be throwing all these people onto the human slag heap because of automation from computers, right? And everyone then, I think they were correct in that, yes, a huge fraction of the economy was in fact this clerical work could be done by computers, and computers were coming along right then and there. The fact is, though, that it took, 50 years for that to happen, for all the reasons that we talked about. So I think that's, the same sort of thing's going to happen this time. It'll, big impacts, but it'll be spread over a long time. 10 years is not a very long time.
Right. Have economists tried to quantify the impact of computers, on the GDP, basically?
They had done a lot to try and quantify the impact of TFP growth, which is a fancy way of saying, productivity improvements of all kinds, very much including innovation technology, versus other impacts on GDP, like, how much education people have, or, how many people are working versus they were sort of just working at home before, whatever, they're sort of in the formal labor market. So lots of that kind of thing. There's been relatively limited attempts to quantify, this much GDP is because of computers, partly because it's just really hard to quantify. You can sort of, on an individual company level, you can do sort of before and after, before computers, they have this revenue, this profit, then afterwards, this revenue, this productivity, whatever.
Yep.
Because the entire economy is changing at the same time, all these demand impacts we discussed before, it's really, really, really hard to come up with a single measurement of what the economy would look like today if there were no computers. It's that's impossible to measure really properly. But an upper bound is how much it has in fact grown, right? It can't be more than 100% of growth. So
Right. And I guess, in these cases, overall, the economy, growth has been slowing down relative to before. And so really, if that's your analogy, then AI isn't obviously going to change things at the level of the GDP.
Yeah. What is it? Don't forget, computers have had a huge effect, and we've had huge GDP growth over the last 50 years. Things are very different in your life and my life today than it would have been if we were sitting here in the 50s. We wouldn't be on this podcast for a start. But that stuff has happened quite slowly over several decades, and we've not had more than, a small number of single-digit percentage points of GDP growth at any given time.
Cool. Okay. So that's the kind of charitable read of where they're coming from, which, it doesn't, my guess is that they'll be wrong, but I see the logic, and it doesn't seem crazy, and maybe I'll be wrong, and maybe they'll just be we told you, it was just another technology. Okay, so the people on the other side of the spectrum who are more optimistic about AI having a bigger impact, what are they expecting to happen?
Yeah, so I think, you've had some of them on the podcast, so I'll be very, very brief on this. But broadly, the claim is that AI could lead to sort of explosive growth. And where that comes from is thinking around not particularly sort of automating day-to-day activities in the economy, but automating the process of innovation itself. So people who work on this think that the most important thing, certainly in, rich, advanced economies for economic growth, is certainly going forwards, is going to be having new ideas, innovations. And as I've written on this, have papers on ideas. However, if you think that one thing AI may be able to do is to speed up the process of research itself, this thing that sort of has the biggest cutting edge, most important impact on economic growth, then you can imagine a sort of different regime where innovation is sort of way faster, and the sort of the cutting edge stuff is progressing very quickly in every sort of different area.
Right. Ideas get much easier to find, which creates this feedback loop of a bunch of growth.
Exactly. Yes. And I certainly think that ideas are much easier to find with GPT-4 and its successors and fine tunings and implementations and so on than before. So I completely am in the camp that thinks that these large language models will have a huge impact on the sort of R&D and the sort of speed with which you can do R&D. And I think the interesting question is sort of what bottlenecks are still there. And, we can have a long discussion about this, and I imagine you covered lots of it with other guests. I think briefly, though, for innovation to actually have an impact on the economy, it has to be adopted, right? This is sort of, that's elided over in all these economic growth models. They sort of elide over, they sort of assume scientists do R&D, and it immediately shows up in terms of like actual economic output, like the goods and services that you and I are consuming. And in fact, sort of, someone can have an idea, but it sort of has to go through, the doctors have to agree to do it and all that kind of stuff, right?
Right.
And so I think all that stuff still applies. And so I think you still have these huge issues of people sort of getting in the way, basically, and things being much slower than they sort of could be if you were like, yes, let's just do everything the AI told us to do. I don't think that democracies, or indeed any states, really will pursue that stronger path, and humans will get in the way.
Okay. I guess my inner Tom Davidson, who, as you said, we had on the podcast, and who has this idea about AI causing explosive growth. I wonder if you'd say something like, yes, those will get in the way for a time, but they won't be bottlenecks forever. Like humans being humans, I guess whoever's sitting there doing a job and is like, I'm not sure I want to use GPT-4 in my job, will eventually, over 5 to 10 years, consider adopting, or they'll just like age out of their profession, and like the new people will be more likely to adopt the new tech. So I guess that's
true
like,
for any particular technology, right? So like something that GPT-4 today can do all this stuff. Like, okay, in 20 years' time, all the people have aged out and it's finally being adopted. But like all the R&D that's now been done by GPT-4 and its successors over that 20-year period, there's a whole nother set of humans now who have to age out and allow those adoptions to be adopted in this world where it's sort of humans getting in the way, right? So there's like, it's always going to be the case that there are humans in the way for any particular new adoption.
Yep. I guess I'm on board with that's a bottleneck, and that'll slow things down, but not that it's a bottleneck that will rule out the more extreme outcomes where growth is really on the explosive end. Why might I be wrong? Forecasting is a tricky business, and I don't think, no one claims to know what's going to happen. Sure.
And it is, yes, I would not rule out anything. Like, I'm not going to sit here and say there is 0% probability of any particular thing. I think compared to most economists, I'm sure I would be like way on the side of thinking this is going to be a really, really, really big deal. But I think compared to Tom, I think I would say just like, if you spend enough time studying economic history, you see all these things that slow stuff down, and those things that slow stuff down look like they're not going to go away. And so I would sort of want to put all that stuff back into his model, and his model doesn't have that stuff in it. His model is kind of assumes there's none of this humans getting in the way, in the ways that we spent a lot of time earlier in the conversation talking about. We can go through, and indeed, Tom and I have had these kind of discussions, talking through, sort of, tell me your bottleneck, and I'll tell you why it's not a bottleneck, whatever, right? So we can have those discussions, and they're very fun to have.
Oh my gosh, I want to have you both on the podcast now.
That'd be fun. But I think this sort of, it's not like it's the kind of thing where it's I can keep coming up with new bottlenecks, and he can keep dismissing them, and we can keep going on forever. And so there's not like a sort of, yes, like there's a nice definitive thing. We both agree that if X was true, then here's the answer. I think, it's not a thing where just, in the next 5 minutes, you and I can talk more about this and sort of reach a nice clear conclusion about whether there are bottlenecks or not in R&D, whatever.
And be like, the bottlenecks can be ruled out. Yeah. Broadly speaking, it sounds like you're in the camp of like AI could have pretty big effects on the economy and on growth, and maybe it'll be on the faster side, maybe somewhat on the slower side. But overall, you are not in the camp of like it's just any other technology like the internet, which like had some impacts on growth probably, but not like world changing. I mean, whatever, they were world changing, but
so I think look, AI could be going from like nothing to the Industrial Revolution was like a massive deal. Given we are in the economic regime we are in already, we've done that 0 to something. So Bob Gordon has this nice thought around sort of once you go from only having outdoor toilets to like having a flushing toilet, a proper modern toilet, like that's a huge improvement in the quality of life. And like almost nothing compares to that. And you can only sort of do that once, going from living in the state of nature
you can add a bidet, but that's only so much better.
Yeah. And so I think there's a bunch of I have some intuitions in that direction of like compared to us in 1800 to today, like we've had so much amazing change. And I believe that AI is going to have another completely incredible, unbelievable set of changes that are going to have huge impacts on GDP in the coming years and decades.
Yep.
I think it'll, the world is likely to be, not unrecognizable, but like quite unrecognizable, in the coming decades. But I think this is perhaps sort of an argument about measurement than it is about like impacts on the world. I think like the way that will show up in GDP, like it might be sort of a bit of a sort of phase shift, regime change compared to the post-war periods. But like, I'm not quite as optimistic as Tom is, I think, about how big that will be in terms of like, I don't think we'll have 30% a year growth happening indefinitely. Like that just, yeah, I think that's unlikely.
Cool. That is really helpful. Okay, so yeah, there's still some space between Tom's view and yours, and then probably some more space between your views and some of professional academic economists. Do we have any early evidence about what trajectory we're following? Like, I guess, are there any indicators that are pointing to more growth or less, or like bigger labor impacts or smaller ones?
So, there's a bunch of things you look at, right, in terms of GDP growth and productivity growth. And like right now, there's like nothing at all to see in those that suggests anything is happening. Now, it's kind of historically always the case that, technology comes along, does amazing things, and it takes a long time to show up in those statistics. There's quite a fun paper from a few years ago by Bill Nordhaus, economist at Yale, called Are We Approaching an Economic Singularity? And he has always he comes up with these sort of very thoughtful tests around like what we would expect to see in the economy if we are approaching this point. And the final line of the abstract of that paper is the tests suggest that the singularity is not near. So that's his sort of glib answer to that question. But I think broadly, economic statistics of the kind that we currently collect are more of a rear view mirror than a sort of looking forwards. And so you're just, if something's really big is happening, I think you're not like, economists are not the people who will tell you, oh yes, it's all showing from GDP. It's like, no, it'll be happening in many other places before economic indicators start suggesting it's happening.
Got it. I want to turn to like the longer time horizon, or like at the point at which things are getting even more extreme because of AI becoming more and more capable. But I guess we should also just flag, like, there's all this complexity in the short time horizon. And so everything we say about the world where AI can automate even more tasks is going to be even more speculative. Yeah, is there anything more you want to say on that, caveat-wise, before we dive in?
So just emphasize it and to say that, we're sitting here kind of prognosticating and, we're just talking about the economic impacts, right? We've like touched a tiny bit on politics insofar as it impacts like labor unions and that very small slice segment of things. But like, there is so much else going on in the world that's going to be really, really important and relevant to this stuff that we haven't touched on at all. So sort of caveat emptor, I think hopefully what we've talked about so far has given people a really good sense of kind of the kinds of forces at play and the things you have to be paying attention to. The final thing I'll just add on top of this is that like, you might say, oh, in one day we'll know what happened. But actually we won't, because we today, looking back, right, it's not at all obvious what the impact of, computers have been over the last 30 years. And many brilliant economists have had stellar careers answering a very specific question in a clever way. But no one's really answered the sort of the macro question of like, okay, right. So all in, what was the impact? And like, what would the world be like if it hadn't happened? Like, we have no idea. And so I think the same will be true in, whether it's in 3 years' time, 5 years' time, 10 years' time, like, what would the world be like compared to if, like, GPT-4 had never been invented, right? Like, we'll just never know because we can't observe a counterfactual world where it didn't happen. So I think that the most we can do is kind of be really thoughtful about the forces at play, and we can use those to reason, I think, reasonably well about sort of the kind of things that are likely to happen and the kind of timeframes it might happen on.
Yeah, that makes tons of sense. Okay, so with all of those caveats in mind...
all that said, yeah.
Yeah, exactly. Ignore everything we're about to say because it's going to be even more speculative and we'll never even know if it's true. We've been talking about a case where AI can automate some small percentage of tasks. And I don't know, do we know what percentage of tasks AI can automate right now?
No, is the answer. But, in terms of sort of the estimates, just to give you a ballpark that the sort of, the OpenAI paper, for example, give, they say something like, I think, 80% of the US workforce could have at least 10% of their tasks affected by LLMs. 19% of workers could see at least half of their tasks affected. Again, affected doesn't mean automated, replaced. It just means sort of, exposed in some way. So these are reasonably large numbers.
Yeah. It's both. It feels both low and high to me.
Yeah,
but it could be really high. It could be 50%. It could be 90%. At some point, we'll probably get to superhuman AI, and it can do all the tasks we can and more. But even 50% feels like pretty different to what's happening now. And I'm wondering if at that point, any of these models will even apply. At that point, is the world just too different for this kind of conversation to be applicable?
Yeah. So I think I'm going to stand up for economists here and say yes.
Okay.
As in the models do apply, all these sort of considerations do apply. So let's think about the question, gosh, wouldn't it be different if we're talking about 90% of jobs being automated? Let's go back to a place we started earlier in the conversation, thinking about agriculture in the US. In 1790, it was a true statement to say, in the coming years, 90% of jobs will be fully automated.
Right.
That's a true fact.
Right.
That's in fact what happened. Now,
that's insane. Yeah.
That happened over a 100, 150, 200 year time frame. And so the speed of this change is kind of really, really important. But then don't forget, back to our talk about, discussion of unions and, the American Medical Association and politics and so on, not to mention all the sort of rational decisions of company CEOs and so on. There's all kinds of forces that mean these things take a long time, even if in theory one could do lots of stuff quickly. There's also this just capital availability constraints and all kinds of things, as well. There's just not enough spare cash flowing around in the world for everyone to do that at the same time. Or there's not enough resources because adopting technology, requires all kinds of work to be done, and you can't just stop the entire economy whilst you retool everything. People still want to eat food and they still want to, fly in planes and whatever it is. You can't down tools and say, no, all we're doing for the next 5 years is switching everything over to LLMs. You only sort of take so many planks out of your boat and replace them while you're sailing in the water at the same time. And so there's all these kinds of constraints that I think are sort of not obvious until you sort of think about them. And so that's point one. So even in a world with 90% of tasks automated, we have been there before. It happened lots of times. And we're still here and things are fine, right? And things kind of they look quite different from 1790, but, many things are still the same. In that sense, things can get weird, but there's some sort of upper limit as to sort of how fast I think they will naturally get weird from an economic perspective. That said, let's think about, what happens when it is 90%, whether that comes in 100 years' time, whether it comes in 10 years' time. So I think there's a few really important things here. So we generally are going around saying, gosh, what if it automated, 90% of cognitive tasks? Big emphasis there on the word cognitive. Many, many tasks in the economy are not cognitive tasks. And back to the old sort of thing we've been discussing all the way through as to, when you automate some kind of thing, suddenly, all the incentives go towards how do you make more value out of the stuff that is left, that is not automated, or that, humans can now do because they've been freed up and they can do something else now. And I think there are many, many, many things that are not cognitive, that, there'll be huge amounts of demand for humans to do.
Does that mean most people are going to be doing a bunch of physical tasks? I guess moving boxes, because I guess that sounds pretty strange to me, even though your conclusion might mean it's not that we'll have loads of unemployment, but it might be that we're most people are just doing a bunch of physical labor. Is that what it points at? So
by physical labor, it would be weird, right, if we ended up sort of lifting boxes in warehouses. I don't think that's where we're going to go. But there's things which we'll get onto beyond physical labor. But within physical labor, caregiving is a physical task, right? If you are looking after an old person who needs care, you have to be physically present and you have to help them do all kinds of stuff. That's what you're there for. That's a physical job, and there is going to be so much demand for that kind of work going forward. And don't forget, most of us spend, 18, 25, whatever years in education before we even start working. And then people seem to be living longer and longer and retiring earlier and earlier. So you're actually only working for, 30, 40 years out of a, 80-year time lifespan, right? And then there's like half of those people maybe are, they're not engaged in the formal labor force because they're looking after young children, or they're just staying at home or whatever it is, right? Or they're rich and retired, or they retired really early. Or they're just kind of, they're working not many hours a week, right? So it seems like everyone these days is switching to 4-day weeks. And it, seems great, right? And in the long sort of history of this, it's amazing what's happened in terms of hours. Minor digression quickly, but like in 1870, the average hours of work, for a working person in America, was 70 hours per week. Right, it was like a grueling life. You were like working like in factories, whatever, like you were made to work really, really, really hard, right? Today, it's 35 hours a week. So we've literally seen a halving of those who are full-time employed, a halving of the hours per week, right? And more recently in the UK, just in the last kind of 30-year period, the UK has seen a decline of 20% in hours worked kind of per worker, like excluding those who are retired, whatever, like among those who are working, right? So there's ever further declines in sort of hours worked because people sort of choose to spend some of their extra wealth on like working fewer hours. That's like a long run trend, right? So per capita, there's like half of a person per capita because of half of your life you're spending in education or you're retired. And then it's like, okay, half again because we're like working way fewer hours now than we ever used to. And so like you keep doing that. And so let's suppose that like in the entire economy, there's actually like 20% of a worker per capita, right? That means that if the entire economy, if everyone was having to be caregiving, right? That there's like not enough humans to go around if we think it's important to have sort of live human carers looking after people who need care. And so if we think that looking after the young children and educating them, and we think we definitely want to have humans involved in bringing up children. We're not going to hand our kids to the robots and say, great, see you when you're 25, right? We're going to have adults be involved. And we think we're probably not going to hand all of the elderly over to robots either. Maybe some we will, or there'll be no other choice. But if possible, you're going to prefer to have human care. That already is like a huge unsatisfied demand that you can see persisting, and the forces, the demographic directions of those forces are sort of ever more in the direction of like a shortage of human labor because we're spending more time in education and more time retired, right? And therefore there's like less people who are able to do this work of teaching and caring, and ever more sort of people who are demanding it.
So it sounds like the story you're telling is one where AI can automate loads of tasks. But because it can do that, there'll be a couple of effects. One is like people might just work less because they can. That makes a lot of intuitive sense to me. I will probably do that.
Yep, and has been happening for a long time. Yep.
And there's historical evidence that that's been happening, and it could just keep happening. But then at the same time, we might just have values that mean that there are some types of jobs that we want humans to keep doing, and that there could be an equilibrium where the amount of work done is basically like the amount of work required to do the tasks that we want humans to do, and then everything else will be done by AI. And maybe that does mean that there's a much smaller overall workforce, and maybe it's because there are fewer people working, and other people, I guess, don't need to be working. Or maybe it's like everybody-ish is working, but they're working for like 5 to 10 years of their lives, and then retiring or working a few days a week. And so there's like a huge decrease overall in like number of hours worked by humans. But it doesn't necessarily go to zero unless we at some point decide like we just really don't value being served by humans in any cases. And I guess that I think maybe the piece that is missing for me right now is like the reason that that's possible is because the fact that we've automated a bunch of tasks super cheaply means that there's growth and a surplus of like goods and wealth that means that people just can work way less. And so I guess I do feel like I had some story before that was like, maybe we'll need universal basic income, but maybe the actual thing is like either we'll have something like that or like natural economic restructuring and equilibriums will mean that like you need much less wealth to have as good or better a standard of living, and at like a lower rate of or a lower amount of working hours. And I guess, I mean, that's just pretty wild to me.
Well, again, it's a continuation of current trends. There's nothing new here, right? So,
right.
You might know, so John Maynard Keynes wrote this famous essay in about 1920, I think, called Economic Possibilities for Our Grandchildren. And he predicted back then that in 100 years, I don't know when exactly, we would all be working 15-hour weeks. Right.
Okay.
And in fact, we got halfway there, right? So we got sort of down to 30-hour weeks, wherever you are now.
He was a bit ambitious.
Right? He was broadly correct. And to your point, it means like sort of the equilibrium here is kind of, if you can afford to retire earlier, then you do. But that means you have to have enough resources to be able to pay other people to, look after you or make food for you or whatever it is, right? So even though you're not working. So, there's still labor demand being created. And so the more people retire early, the more work the people who are left have to do. And so the more wages they have, and so the more it's potentially worth, I don't know, working a bit longer, depending on which effect dominates in terms of you want to work more because you can earn more versus take advantage of being able to retire early because you make more money. Except there's like these things, again, always go in different directions. But there's definitely a sort of long run equilibrium there, and it's going, and sort of the state of that equilibrium is going in one direction, which is we're working less, and we are, I think, happier for it.
Yeah. I guess part of me is like, that's a pretty nice story. That's a story where people get to have as much nice stuff or more stuff and work less. And that just sounds pretty good. So nice.
Yeah.
Yay.
That's the story of the last 200 years, right? That's exactly what's been happening.
Right. Yeah. Well done. Yeah. Well done, humanity.
We've also done lots of terrible things, obviously. Not we should obligatory pointing out that we've destroyed the planet and so on, right?
Yes.
But like being purely self-interested for right now and not caring about our grandchildren and not caring about the planet and other stuff. Like we have more stuff and we work less, and it's nice for those people.
Well, hopefully, all of this surplus that we're getting is also going to help us solve some of these problems.
Exactly. 100%. Yes. And that's kind of, the hope is as you sort of ascend Maslow's hierarchy of needs, you suddenly start being like, oh no, you know what? We can afford to do this now. We do care about the planet and we do care about, etc. Yeah.
Yeah. Is there like a dark side to the story? One thing I'd worry about is like, as seems bad now, some people work much harder than others. Some people have much less than others. Is there a story where this exacerbates inequality because like many people who are wealthy now work less and less and less, but some people work loads still, and that's unfair? Or is the like overall increasing wealth and productivity going to lift everyone up such that at least relative to now, basically everyone's better off?
I think this is politics really comes in here, and things like the minimum wage become really, really, really important. There are interesting arguments about whether the minimum wage increases or decreases the total amount of labour demand. I think there's not a clear consensus on that. But I think it is pretty clear, at least among labour economists, that if you look at inequality as sort of income inequality over the last few decades, particularly at the sort of the lower end, like a really, really, really important thing is where the minimum wage is set at. And so if you're saying, maybe in a completely free market, human labor would be at such a low level that you sort of have to be, working many more hours than you would like, the government can just say, you know what, we're going to sort of do the equivalent of increasing workers' bargaining power. We're not going to do that. We're just going to literally set minimum prices higher. And, those people are much happier, right? They're getting paid more. There's whole debates we can have about the impact of minimum wage and sort of whether it's good and bad and so on. But broadly, thinking about if you're an employer and you're employing workers, the worker is producing some output, some amount of stuff, and they get paid. And they certainly have to be paid less than their output because they were paid more, than the company would literally lose money by employing them, so they wouldn't employ them, right? But generally, there's sort of some amount that produces work, the worker is producing. And in some cases, the worker captures most of that amount. In other cases, they capture very little of that amount, depending on how much bargaining power they have, whether they're in a market where there's loads of people just like them, or like they're the only person who can do what they're doing. So this sort of surplus gets divided between the worker and the employer. But broadly, I think there's sort of lots of reasons to think that the wages you can earn as someone with kind of the least skills in society, that wage, keeps ratcheting up over time, whether it is because of increasing minimum wage, whether it is because of increasing technology, increasing your productivity, whether it is because of increased education. That's like the biggest thing, right? People get so much more education these days than they did, 20 or 40 or 100 years ago.
Right.
I think there's a quick side note on that. Like it's amazing. You just think, just forget, like, if we went 100 years ago, like, most people would be illiterate. So if you go on the tube in London, the underground, right, there's always like interesting sort of coloured patterns on the walls for different stations. The reason they are there is because most people on the underground, when the underground was built, could not read, and therefore they had to have some other indicator of what station they were at, right? I mean, we forget how sort of uneducated everyone was 100 years ago, right? And the story of the last 100 years, the US was kind of fastest here. They got their act together by far the fastest compared to most of the economies in terms of educating people much more at the sort of high school level and beyond. But sort of Europe sort of eventually caught up, and indeed, the rest of the world. We went from this amazing amount of sort of what you might call educational upgrading, and not only do people become literate, we're now in a world where half of people are sort of getting degree level qualifications, right? And I don't think that necessarily will stop. I think that can sort of keep going and going and going. Maybe the institutions will change, and I certainly personally hope they will. But I think in terms of can people keep getting more education and learning more? Absolutely. And that's as much about people who sort of currently are only getting up to age 18 level, as much as it is about those getting masters, now getting PhDs or whatever, more vocational training. There's so much more room for every human to learn more stuff. And to avoid going on another huge tangent, but obviously GPT-4 large language models have a huge amount of impact, will have a huge impact very quickly, I think, on education in terms of how easy it is to learn new stuff, and how personalized that can be, and how well explained it can be, and all that kind of thing. And so I think we're also hopefully about to see a sort of golden age for education, and people who maybe would have been more quote low skilled, today or 50 years ago, are now able to be much closer to what we now regard as a good college educated person. Everyone's going to get to that point, or as kind of it suits them and the kind of things they want to do. The kinds of things one might want to cover in a college education might look very different, and it'll be much less around sitting still and studying a book, and much more about other things. And those things, I think, will be broadly available to everyone. Or certainly, that should be one of the first tasks of society, is to make sure that's the case. And I think we will get there. Yeah.
I guess one reason to be pessimistic that, again, we've covered in other episodes, but just to add the caveat, AI also poses huge risks from misuse and from unsafe development. And are there things besides that? If we were to both align AI and sufficiently prevent misuse, are there things besides that worry you? Or are we just going to keep trending toward this pretty great sounding world where we work less and have more?
Again, I would emphasize, I've just been focusing on the sort of economic picture here, right? So think about, COVID, right? We could have sat here 5 years ago and talked about how great the economy will be in 2020. And yet it was way worse than we expected because of this thing that's kind of extra economic. And yet it sort of caused a huge negative impact on the economy, right? So what I'm talking about here is just sort of set aside, America, China, huge World War III, set aside the alien invasion and the COVID Mark II and the AI's takeover and the asteroid and all that stuff, and assume away all of that, what happens in the economy?
Got it.
And I think there's that sort of, broadly positive story. And I should emphasize it's positive because I believe, I think, pretty fundamentally in the sort of the power of sort of democracies, and I guess maybe other forms of government as well. I'm less sure about those, but to ensure that humans being humans, right, and slowing things down, the humans actually do successfully slow things down, and that generally benefits some humans more than others, but overall it sort of keeps things manageable for us.
Okay.
And I think that will continue because there are all these natural forces that stop things happening as fast as you might think if you were sort of naively thinking, hey, this is possible now, surely it's going to be everywhere tomorrow. It's like, no, it doesn't quite work as fast as that. It doesn't work that way. But, let's step back and say, is democracy going to survive for other reasons? Is there going to be a, US-China war, all that kind of stuff? Like, yeah, I think I'm probably quite pessimistic about all of that stuff, actually.
Okay.
But on the pure economic side, I think I sort of, I'm perhaps less worried, having thought about it quite a lot than others. Yeah.
Okay. So we should think of this story as the story of what could be if we manage a bunch of these risks, and
yes.
And the economy does what the economy does, which is basically relatively efficiently allocate these resources such that people broadly end up having more, working less, and being better off.
Correct.
Cool. That makes sense. And I really hope we solve these safety issues because I do find this story just very, very inspiring. It would be pretty incredible to get close to there.
Let's hope we get to experience it. Yeah.
Let's push on to our final topic. So I want to talk about some concrete career advice. A lot of our listeners are interested in how the development of AI should influence their own career planning. And I guess to start, to what extent should people be taking all of this AI progress in mind when making their career plans? Is it even a given that they should be?
Yeah. So I think I'm going to start with a non-answer that hopefully is still actually interesting, which is they should totally be taking AI into account they should be using it to help them with career planning. Like, I was thinking about careers as a, 20-year-old. It's like, you have no idea what these jobs actually involve. You can read the websites in the company, and these days you can read the wonderful career profiles on the 8000 House website, but you still often have no idea what's actually involved in many of these things, right? And so, if you're lucky, maybe you know someone who's done the job, but often you don't. And now you can literally go on Claude or whatever and say, hey, please pretend you are a McKinsey consultant. Do you love your job? Please be honest. I just did this. And the answer was, I have mixed feelings about my job as a McKinsey consultant. It gives you a long list of pros and cons, right?
Oh.
So,
that's really funny.
Right. And so you can do this for all kinds of stuff. The thing I always remember when I was, at that point of choosing first careers, I was like, but what do you actually do all day? Like, you can give me all this amazing, exciting stuff around the impact and the great colleagues and whatever, but what are you actually doing, and what's the division of your time? And these language models actually often know the answers quite well, although they certainly are much better than whatever your first guess is. And so they can help you with that. They can help you brainstorm who to reach out to. They can help you prepare, questions to ask someone that you're having a sort of coffee informational chat with. You can tell them what you're interested in, and it will suggest careers for you. You can tell it, you are my career coach. Please figure out what questions to ask me to help me decide what to do, right? All these things.
Nice.
It can just do an amazingly good job out the box. And then, okay, in terms of beyond that sort of process piece, in terms of okay, how will it actually affect the choices you make, the fact the world is changing in this way. So I think both it will massively influence the economy and sort of what one should think about doing, but at the same time 90% of people are not going to be thinking very hard about it as they make their sort of career plans. So it's not you're going to be completely disadvantaging yourself by not thinking about it. You're going
to be totally left behind.
Yeah, it's more just if you think about it, then you're instantly in the top 10% of people thinking about these things.
Okay.
And so I think a few sort of concrete thoughts. I think the easiest sort of generic piece of advice is you should think really hard about how AI is going to be useful and impact the particular things that you care about and might want to work in. I think there's going to be, there's a shortage of AI researchers directly right now, and certainly alignment researchers, but people who are any old other thing, so people in government, or people working for, I don't know, all the kinds of, career profiles that you'd like to write about, people know about those, and they know about AI in some real detail. You are instantly going to have a very rare and valuable skill set. And so learning about AI sort of as it is for its own sake, and then thinking really hard and carefully about how it interacts with the kinds of work that you're doing, but sort of really specializing it to your particular industry, like thinking in great detail about particular tasks, and thinking about sort of how whole production processes could be reimagined, and thinking about as well, we have not talked much about the dangers and the risks and the errors and so on. It's come up in passing, but there's, many podcasts we could have just on that. And, I think you've had some on that. And so thinking about those in great detail and like being really thoughtful about the risks in any particular application area, as well as sort of the more general and scary ones. I think that's just going to be, you're going to be so unique and rare and valuable that you're going to have an instant massive leg up. So that's a sort of one generic piece of advice. The other generic piece of advice as well is you can also, I think, now upskill much more quickly for any particular question or career path, right? So you're like, what does a consultant need to know? What does a grant evaluator need to know? What does a safety researcher need to know? Like all those specific things, you can actually use GPT-4 or etc. to teach yourself, or to give you a huge leg up in that sort of self autodidactic exercise, teaching yourself, than you could before.
Okay. Great. Good advice. What jobs would be sensible to go into now because demand for them is going to go up?
So I kind of think of career paths more than like specific jobs. Specific
jobs, sure. Yeah. And I think that is, what I mean.
But and these things will kind of, evolve a lot over the next, coming years for all the reasons we've been talking about. One theme that's come up a lot, I guess, in this conversation is entering a highly regulated industry you're going to be more safe and not exposed to radical changes than entering one that is not regulated. And so if you ask for a sort of nice, steady, stable thing, go after the sort of the strong unions and the / professional bodies like the American Medical Association, because you'll probably have a sort of relatively easier time of things. If, however, you're someone who wants to lean into risk, which I probably many people should, and much more than they in fact do, certainly when you're young. Go for the areas where there's kind of the most change and the most likelihood of AI actually having a sort of short, more sort of near-term impact. So those are kind of like industry level thoughts. In terms of like specific what you're doing day to day, like occupation or sort of skills. So I think, first a sort of generic thought. So one is like, you want to be adding value on top of large language models. So pretend that doctors are not regulated. Okay, so imagine that like we can just change things for everyone. It's a pure market system. In that case, what I think I expect to see is very quickly GPT, Claude, whatever, starts, or fancy startup that just raised lots of money, I forget what it's called, that's like just going to build a health LLM. I'm sure with lots of these companies now, right? They can just like do a much better job than the doctors of diagnosis and prescription and all kinds of other stuff. Particularly the kind of the GP sort of more entry level stuff that requires like wide body of knowledge and everything's changing all the time and you don't have much time with people and whatever, right? And not that much physical stuff either. And so, in that world, like what does a human do on top? Well, probably in that world, but certainly for the sort of the GPs of this world, again, in the pretend world where it's not regulated, so this is not going to happen, I claim, but supposing it did, you would say probably that, we don't need GPs to have anywhere near as much training as they currently are required to have, because the algorithm can do a much better job of diagnosing and prescribing. And now what their job is doing is really much more about the empathy. And it's much more, the small number of things which are more sort of physical, sort of I had to smell you or something, until we have smell GPT. I'm sure it's coming, but for now, humans have to do that. And, and sort of, they're making you feel, appreciated and loved and cared for and all those kinds of things. Now, the thing is, right, is that sadly, or, I guess in a sense, luckily, for us, but also sadly in terms of sort of what it means for wages, if you're going into a job where it's like, all you're doing is you're layering on empathy on top of GPT in a sort of in-person setting, that is just, there'll be tons of demand for that, but it won't be particularly, like that skill of empathy is not that rare, and so you won't get paid that much to do it. It's like not as anywhere near as rare as the doctor who today, right, who's kind of, there's not many of them and they have to do all these years of training and they get paid loads of money.
Yeah.
Right. So it's sort of adding value on top of language models, and the value you're adding is somewhat rare. So what are the kinds of value you can add? The first thing is sort of the generic point. Now let's be specific. Like what actually are those things? Okay. I think the first thing is social skills. There's wonderful work by an economist called David Deming, who's at Harvard, and his kind of breakout paper a few years ago was characterizing occupations in terms of whether they've acquired high technical skills or high social skills. Or in particular, sort of 2x2 grid of like low technical, low social, low technical, high social, etc. Right? And looking sort of over the last, 30 years at wages for people in these different buckets. And it turned out that the only kind of people or jobs that have seen real sort of outlier, fantastic wage growth are those with high technical skills and high social skills. So if you just have high social skills and no technical skills, you've done pretty averagely. If you have just high technical skills and no social skills, you've also done pretty averagely, certainly in terms of sort of wage growth in recent decades. And if you've got neither, then even more so, not so good. Only those who've got both have done really well. And overall, there's been sort of a hugely increasing demand for social skills. I think that's only going to continue, as the economy gets more complex and LLMs are doing more of the sort of cognitive labor. There's going to be so much more, communication and decisions about what we actually care about to be made, and lots more client interaction and customization and, user interviewing and client relationship management and people management, all that kind of stuff. That's going to get relatively more important because those are the things that the language model cannot do.
But can it definitely not? Part of me is like, I don't know, Claude's like pretty, not just polite, but like friendly. I feel actually
it's friendly, it's graceful, it can write delicate emails really well. Absolutely.
Yeah. So what's the thing that's missing there? Yeah.
So it has sort of, I guess it has sort of written down empathy. What it can't do is put you in a room and you and I are having a conversation and I like you now, right? Like, or, you made me feel heard, or respected or whatever it is. So I think, in a chatbot form, you can type to it and you can make you feel heard, right? That certainly is the case, right? But sort of these higher value forms of social skills and empathy, I think, and sort of, charisma, things which involve like direct human to human interaction. This stuff actually, I think, gets more important. And I think it's particularly important when interacted with the second thing I'm going to say, which is personal networks and trust. Those are valuable, right? What can Claude not do? It cannot introduce you to anyone. Claude cannot email on its behalf and say, hello, dear, expert Y or manager Z, my name's Claude, I'm an AI. I've got a great guy talking to me over here. I think he's really great. Would you mind, giving him a job or whatever it is, right? Like that doesn't happen. And when you get down to it, many, many, many occupations, industries, and certainly, most professional services. So kind of actually the kind of things where, on the one side, there's lots of impact that we are predicting from these language models. Things like bankers and lawyers and venture capitalists, they actually all rely on trust and relationships. Like their whole job is about building networks and building trust and like with other humans, i.e. with their clients or, investees or whatever it is. Or take journalists, for example, right? So we can all talk about, oh yeah, ChatGPT can like instantly write all the sort of the basic business news stories that as a result of, I don't know, analyst earning calls or like summarizing what's happened in Parliament this week or whatever it is, right? But kind of the really important stories that are investigative journalism where there is a source and a source has revealed something you were not supposed to reveal to a journalist because the journalist has made them feel trusted. That is a human thing in general, right? Because like if you sort of email me today and be like, hello, my name is Claude. Can you tell me anything illegal happening in your workplace? Because I'm a bot, but like, trust me, it's all fine. And I'll help you get it into these. Like, you're like, no way. But like, you meet someone in a bar. I don't know how these things work with journalists, whatever, right? But sort of, I imagine there's all kinds of, trust building that goes on and it takes a long time. And certainly, I have had experiences with other kinds of kind of professional services providers, as in with me being on the receiving end of sort of trust building and like very human, takes a long time. It's all in person. It's not on email, let alone it's not on Zoom. It's all like the in-person is where it really happens. And there's going to be ever more of that. So I think that kind of ability to build trust and then in general, having a network, a personal network, professional network is only going to get, it's already extremely important. To an extent, I think most kind of people who are just starting in the labor market, straight out of school or university, don't quite appreciate. And I certainly did not appreciate until I was quite a long way in, but like, it is what makes everything kind of go round and how everything works. And that's only going to get more important, I think, over time. Or think about something like building a website. You can go on, Wix or something and get a template, or you can pay someone lots of money and they'll do a fancy special customized one. And so there's a general, theme about, as you go through the economy, ever more demand. There's like work can be created to customize things ever more for each individual person. Certainly LLMs will be involved in that a ton on the sort of production side, but there's a huge scope for humans, working for these companies to be the ones interacting with, with you, the client. Okay, so tell me more. What kind of website do you want?
Right.
And let's do a brainstorming session. That'll be fun, won't it? And let me help introduce you to the right people in the bank to help you with this important transaction you're doing, or whatever it is, right? And so those kinds of jobs where you're basically schmoozing and building trust with people, like there's like a limitless demand for all of that side of things.
Cool. Wow. Okay. That's loads of things, but it sounds like the theme is, charisma, networks and trust, general people skills, things that require people to be like, I like you and I trust you.
Yes.
Yeah. Is there any more on that?
So beyond the sort of social skills and sort of trust and that sort of things, I think there's another category here, which is around sort of management. We've touched a bit on it, but I think managing teams of AIs is going to look a bit different from managing teams of humans. And we're going to need lots of both. But I think the sort of thing that's really new here is, how do you manage
teams of AIs?
All these swarms, hopefully not literal swarms, but you as a whatever you're doing, you're a lawyer or you're a researcher, whatever. You've now got thousands and thousands of paralegals or research assistants equivalent. Like, what do you do with them and how do you orchestrate them? I think, there'll be plenty of places throughout the economy where people figure out standardized ways of orchestrating that kind of work, and it'll be embedded in software and it'll have performance guarantees and whatever. But there'll be also tons of the economy, the more sort of creative parts. I guess, I very much include artists and others here as well as the more creative kind of researchers or indeed lawyers, right? Where it's like, no. You can't use software for this. You can't use a sort of pre-baked sort of prompts and input-output understood thing. Like, your job is to figure out, here's a completely novel problem. It's like edge of the art. You've got all these very smart RAs equivalent. Like, what do you ask them? What do you do with them? How do you check what they're telling you is correct in this non-understood area where it's you can't have performance guarantees because it's brand new? Right, so that will be a huge, really important skill. I think, to be honest, that today is now an incredibly important skill, particularly in research. If I was, in the middle of writing papers right now, I would, if I think back to sort of writing that paper we discussed, about the impact of AI on the job market, that paper would have been so much easier to write in so many ways if I had access to GPT-4. And I would have written that paper, it would be much higher quality, and it would have been produced in probably a third of the time or a fifth of the time or something. And so if you are a researcher and you're not using these things or figuring out how to use them right now, then I think people who are thinking about that are going to probably outcompete you quite quickly, at least if they're competing directly with you in some sort of, research niche or whatever it is.
Cool. Okay. I guess flipping the question around, what jobs will not be sensible to go into now because they'll be more automated soon, maybe completely?
That's a trickier one because there aren't that many jobs which consist only of, the things that GPT-4 can do. So, there are examples. So there was a news story recently of, a bunch of people, both in the US and I think often in the Philippines as well, who were kind of content writers, very much sort of minimum wage type content writers, sort of content factories, right? And literally, it was very direct and very clear. They were laid off and they were told directly it's because ChatGPT is better than you are, right? Because all they were doing is they were kind of outsourced labor. It was text in, text out. And I was like, you know what? We don't need that anymore. And so probably shouldn't go and do that. But I think there's tons of writing jobs that potentially, now you can be even better at because of GPT, and you can earn more money in or have a better career because you're bringing a really important extra thing. So I guess one thing we haven't mentioned but is really important is what you often will bring is the context, right? So we obviously have to give context to these algorithms when we sort of ask them questions, right? And some these days, often the context is like, what do I want? And like, it's an effort of imagination to sort of figure out how to sort of query yourself first about what you want, and then put that into the algorithm. And if you're in an organization of some kind doing work, or indeed working by yourself to be something of value, there's going to be a ton of context out there that the algorithm is not going to, it sort of by default pays attention to nothing, but has like everything it could pay attention to literally anything. And so you're sort of pointing it to a bit of the space of things it should pay attention to. And that might just be things it already knows about, but also might be, things that are just happening in the world, or things that are secrets that only you know because you've spoken to someone who knows something and that's not on the public internet yet, or whatever it is. And again, there's a lot of that in the world. And there's a huge amount of the economy of economic value is people knowing things before other people know them, or other kinds of sort of context that is not public. Huge factors of the economy are sort of things that are secret, basically, or not sort of not publicly available. You, as a human, can build up your stock of secrets. And those secrets could be you did some user interviews with some humans and you talked to them, then you persuade them to talk to you, and no one else can get them to talk to you, and you ask them the right questions, and then you now know a lot about this kind of person, and that's really helpful for building products for them. Or you've been talking to politicians about what they really care about when it comes to this area of regulation, and like they were not taught to anyone, but they taught to you, and you're the only person who knows what these different politicians think about this question, right? Again, Claude cannot do that. GPT-4 cannot do that. Only you can do that. Maybe they'll help you write the questions, but like only you can get the context. And so, other areas of which there are many where kind of the scarce thing is the context, feels to me a pretty safe bet for the future.
Nice. Yeah, that makes sense to me. Moving to another topic, we actually haven't talked yet about what you're working on now.
Yeah, so what I'm working on now is actually a secret project that I can't yet tell you about. But I can tell you a little bit about the motivation and wider context. So,
wow, that sounds great. And what a what a way to pique listeners' interest.
Yeah, apologies. I'm not trying to do that. In government, one of the things that one does is work on strategies. So one thing the government does, it writes lots and lots of strategies, and you end up with strategies coming out every ears. And so I was involved, tangentially or very directly in the UK government's national AI strategy, national quantum strategy, national innovation strategy, national space strategy,
wow,
the integrated review of security, defense, development, and foreign policy, all these different things. And I started to notice a pattern, which was pretty much every single one of these strategies had sort of pillar one, paragraph one, clause one was always like the most important thing is talent. The most important thing is we need more people with the right expertise in this particular area, whatever it is, throughout the economy. So that might be, in companies, in startups, in university labs, in corporate labs, in the government itself. And that was always sort of the most important bottleneck. So I did a lot of work figuring out, how do we solve this? And sitting in the government, you might think you have all kinds of levers to pull to help solve sort of talent problems. And we did a lot of work on the sort of the quote sort of easy thing you can do, which is making it easier for people with the right skills, these are like very advanced skills to come to the UK from other places. But there's only so many of those people, and every other country also is trying to attract them. So you have to do much more to actually, build, grow the talent right here. And so I did what seemed to me to be the obvious thing, which is going to the existing higher education sector, because we're talking really here about expertise at the level of at least a master's degree, if not a PhD and beyond. And had all kinds of meetings with vice chancellors and, all these kinds of people. And, our universities are amazing. Like they are one of the jewels of this country and the world. But it's also the case that they are not really naturally set up to help with this problem at the requisite scale. So my tagline of what we need is more experts fast, right? That's what we need. So for any cause area, if you like, so with policy area from within government, maybe here we talk more about cause areas. So taking AI safety as another example, right? What we need is more people who can do this work, do this research, as fast as possible. And you go talk to universities, and I will try and avoid naming names, but there's a few problems they have, right? So one problem is that they often don't actually have the expertise. So in many areas, like these kind of all these ones I mentioned in terms of all these strategies, these sort of cutting edge technologies, or the place with the most societal importance and urgency, are also the places where there's sort of often the most investment going into these areas sort of anyway from the private sector. And often the cutting edge is not in the universities. It is in these corporate labs. So AI is the most obvious example, right?
Right.
And what this means is that, there were a bunch of great researchers in these areas at, I won't name any particular universities, but sort of the ones you would obviously think of as like sort of the really good ones, right? They had many of these great researchers 10 years ago. But 10 years ago, they all left, and they're all at DeepMind now, and similar companies, right? Why would you stay in university when you can get paid 10 times plus as much and have way more resources and be on the cutting edge, right? So these universities have really been sucked dry, many of them, of the best talent and the people who can sort of do the teaching. And the other problem is that they are governed generally by the sort of the faculty as a broader body. And because they have these constraints in terms of space, physical space constraints for the most part, that means that if you want to have more, say, computer scientists, which you may or may not think is a good idea, but suppose you think it's important to have more computer scientists being trained, that means that, some professor of, English literature has to say, that's great. Yeah, let's go for it. I will happily accept fewer English students in order to make room for more computer scientists. At least that's the way it works in the UK. And believe it or not, that generally doesn't happen because people don't want to say, sure, let's have fewer of my people and more of your people. And because of the governance, sort of these people actually make the decisions. I will name one name. I believe these numbers are correct. Last year, Oxford University accepted something in the region of 300 people to read English language and literature, and something in the region of 30 people to read computer science across the entire university at undergraduate level, right?
Whoa.
It's completely crazy, I think, to most people.
Yeah, that's wild.
Right? And then picking another quick example, he puts on Oxford, so let's pick on Cambridge as well. How many people do you think are able to be accepted or enrolled in Cambridge University's course on NLP, so natural language processing, which is the bit of AI that ChatGPT and all this stuff sort of kind of came out of originally. How many places are there on that course? 15, right, per year, right?
No.
So this is kind of not going to solve what we're trying to what as a country, as a world, we need to do. And also these courses, again, just to pick on Cambridge, this course is based on a textbook from 2008. So not only pre-large language models, like pre-deep learning, it's sort of incredibly out of date. And so I decided, after lots of sort of banging my head against these sort of 1,000-year-old immovable brick walls, that it would be easier to solve this problem by actually leaving government and building something new that would directly solve the problem than staying in government and trying persuading other people to solve it, which was not going very well. So I can't say much more than that at this point because it's all kind of under wraps. But so I hope that gives a sense of what we're building. And so I guess, can't say more than that other than probably when this goes out, I'll be hiring. So
amazing.
If you're interested in learning more or being involved, please get in touch. I guess we'll put my sort of details on the show notes, but my email's on my website, which is michaelwebb.co. And yes, please do get in touch.
That's really exciting. And I can't wait to hear what that is. But it sounds like relieving some of the talent bottlenecks, maybe around, is it STEM issues in particular?
Yeah, well, I think we'll start with AI and AI safety in particular, because that's where it feels like there is the most important bottlenecks right now. Yeah.
Great. I would agree. I guess we'll all just eagerly await for whatever that is to become public. Awesome. But thank you for the teaser. So this has been a marathon interview. So we should go to our final question now. Yeah, I'm curious. You've been a choral conductor and an organ scholar, and I think this is super cool. I have sung in choirs for many, many years, and I love music quite a lot. And it seems like we might have that in common. And I don't really know what I think about AI creating music yet. So I'm assuming that you're pretty passionate about music. Do you have a take on how you'll feel about AI music once it starts getting really good?
I think it already is really good under some definition of really good, right? They can already produce music that like experts can't distinguish from the real thing for like many, many genres, and that's only going to sort of continue. I think though that sort of, in a sense, sort of composers are not the scarce thing. So always compositional ability, at least, that sort of pure, can you replicate some style or whatever it is. I think the scarce thing, so one is, for me, what I love about music is it's all about the live performance. And, you know, in choral music, that's often, you know, it's in a concert hall, it's often part of a church service. And there's a sort of, you know, a choir of people who sort of come together every week. And those people, or indeed every day in some cases, right? And like that is something that is very, very, very special. And indeed, some of these choirs, you know, there's like some in Oxford and Cambridge colleges that haven't missed singing a service for like 800 years. Like there's this one continuous thing, and there's, you know, they've been singing some of the same music for 800 years that they've been singing, and they're singing a whole bunch of, you know, newer stuff as well.
Right.
And as a human, I really value that, and I value this sort of huge, fascinating sort of tradition, both of the music and where it's come from, and of the kind of people who've been singing it. And it's a really, you know, it's a religious experience, right? Sort of listening to this music, or call it what you want, you know, transcendental. And it's, you know, listening to it through your headphones, through a recording. It's definitely not quite the same as being there, particularly in these kind of very special times and places. And so on the performance side, I think it's like very clear that we are gonna, you know, sorry, not sort of to jump back into the sort of the meat of the podcast, but like we're gonna strongly want to see ever more performers, human performers, like doing performing arts, like seeing them live. That's been a trend for a very long time. But in terms of back to the AI music, I think I'm sure we'll also, you know, we're seeing composers who'll be playing around and doing cool stuff using AI tools. You could imagine. And we're kind of already here, one suspects, with, you know, with Spotify being able to just, you know, on the fly, you know, generate some music that it thinks you will like based on your, you know, listening history. And like,
which I love. Which
many people love, right? And Spotify love because it means they don't have to pay any royalties to real musicians. They can just like have the AI generate it, and then they don't have to pay for it. It's like pure money for them. And so that, I'm sure, will continue happening, and there'll be, you know, lots more of that. But again, because there's so much of that, there's like literally unlimited quantities of that. The stuff that becomes ever more scarce and therefore valuable is like the human who's like, yes, the human wrote this, and here's the backstory of the human, and here's why they wrote it, and here's how it links to a whole sort of things they've written before, and here's how it interplays with, you know, here's the human's interpretation of you know, relationship to sort of this other music that we've, you know, all also know and love. And so on and so forth. And like, that's what you see today in I think basically all art forms. So precisely because AI generated art is unlimited and we can all get as much of it as we want at all times, it almost means the human made stuff, as for many other areas, becomes ever more interesting and valuable when set against this, you know, unlimited sea of, you know, undifferentiated or, you know, possibly differentiated in a way that one can't get one's head around, sea of AI generated content.
Our guest today has been Michael Webb. Thank you so much for coming on the podcast, Michael.
Thanks for having me. It's been a real pleasure.
If you liked the sound of that new initiative Michael was describing to really increase the number of experts in AI safety, or if you're generally interested in accelerated learning or in AI safety or education as a cause area, then some exciting news is that Michael is now hiring for that project that he was talking about. You can find out more about that new org at quantumleap.education. I didn't know that there was such a thing as .education, but yeah, quantumleap.education. Of course, we'll also stick a link up in the podcast description. And if you liked that conversation, two related interviews that Luisa did earlier in the year are episode 150, Tom Davidson on how quickly AI could transform the world, a very good one to pair with this episode, and 146, Robert Long on why large language models like GPT probably aren't conscious. And some interviews I've done, which you might like, are episode 158, Holden Karnofsky on how AIs might take over even if they're no smarter than humans, and episode 155, Leonard Haim on the compute governance era and what has to come after. All right, the 80,000 Hours podcast is produced and edited by Kieran Harris. The audio engineering team is led by Ben Cordell, with mastering and technical editing by Simon Mansour and Milo Maguire. Additional content editing by Luisa Rodriguez and Katie Moore, who also puts together full transcripts and extensive collection of links to learn more, as always, available on our website. Thanks for joining. Talk to you again soon.